Alright, I'm back for the seventh part. We're gonna do the fractions again. We're gonna continue fractions. I finished the fourth quiz and where is that? Okay. So this was the last thing I did yesterday. And now we're gonna do this part. We're gonna finish all this thing today. What am I recording? Okay, let's go. Visual adding fractions.
Let's see if we can calculate what 5/6 plus 1/4 is. And to help us, I have a visual representation of 5/6 and a visual representation of 1/4. Notice I have this whole hole, I guess you could say, broken up into 1, 2, 3, 4, 5, 6 sections, and we've shaded in 5 of them. So this is 5/6. And then down here we have another hole, and we have 1 out of the 4 equal sections shaded in, so this is 1/4. And I want to add them. And I encourage you at any point, pause the video and see if you can figure it out on your own. Well, whenever we're adding fractions, we like to think in terms of fractions that have the same denominator, and these clearly don't have the same denominator. But in order to rewrite them with a common denominator, we just have to think of a common multiple of 6 and 4, and ideally the smallest common multiple of 6 and 4. And the way that I like to do that is I like to take the larger of the two, which is 6, and then think about its multiples. So I could first think about 6 itself. 6 is clearly divisible by 6, but it's not perfectly divisible by 4. So now let's multiply by 2. So then we get to 12. 12 is divisible by both 6 and 4. So 12 is a good common denominator here. It's the least common multiple of 6 and 4. So we can rewrite both of these fractions as something over 12. So something over 12 plus something over 12 is equal to. Now there's a bunch of ways to tackle it, but what I want to do is I just want to visualize it here on this drawing. So if I were to go from 6 equal sections to 12 equal sections, which is what I'm doing if I'm going from 6 in the denominator to 12 in the denominator, I'm essentially multiplying each of these sections by, or I'm essentially multiplying the number of sections I have by 2, or I'm taking each of these existing sections and I'm turning them into 2 sections. So let's do that. Let me see if I can do it pretty neatly. So, do a little bit like that. So it'll look like that. And then, whoops. Let me do this one. I want to divide them fairly close to evenly. I'm doing it by eye, so it's not going to be perfect. So then you have that one, and then last but not least, we have that one there. And then notice, I had 6 sections, but now I've doubled the number of sections. I've turned the 6 sections into 12 sections by turning each of the original 6 into 2. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections. So if I have 12 sections now, how many of those 12 are now shaded in? Instead of having 5 of the 6, I now have 10 of the 12 that are shaded in. So I now have 10 twelfths. 5/6 is the same thing as 10 twelfths. Another way you could have thought about that, to go from 6 to 12, I had to multiply by 2. So then I have to do the same thing in the numerator. 5 times 2 is 10. But hopefully you see that those two fractions are equivalent. That I didn't change how much is shaded in. I just took each of the original 6 and I turned it into 2, or I multiplied the total number of sections by 2 to get to 12. And then instead of having 5/6, I now have 10 twelfths shaded in. Now let's do the same thing with the 4, with the 1/4. Right here I've depicted 1/4, but I want to turn this into something over 12. So to turn it over something over 12, each section has to be turned into 3 sections. So let's do that. Let's turn each section into 3 sections. So that's 1, 2, and 3. So then I have 1, 2, and 3. I have, you can see this is going 1, 2, and 3. I have 1, 2, and 3. And so notice, all I did is I multiplied, before I had 4 equal sections, now I turned each of those 4 sections into 3 sections, so now I have 12 equal sections. And I did that essentially by multiplying the number of sections I had by 3. So now what fraction is shaded in? Well, now this original, that was 1 out of the 4, we can now see is 3 out of the 12 equal sections. It's now 3 out of the 12 equal sections. And so what is this going to be? Well, if I have 10 twelfths and I'm adding it to 3 twelfths, well, how many twelfths do I have? I'm going to have 13 twelfths.
Yeah.
You can see it visually over here as well. Up here in green, I have 10 twelfths shaded in. Each of these boxes are a 12th. Let me write that down. Each of these boxes are 1 12th. That's 1 12th. This is 1 12th. So how many? Let me write that down. Each of these boxes are 1 12th. That's 1 12th. This is 1 12th. So how many twelfths do I have shaded in? I have the 10 that are shaded in green, and then I have an 11th twelfth, a 12th twelfth, and then finally a 13. The 13th twelfth is one way to think about it. Let's see if we can figure out what 3/4 minus 5/8 is. And we have 3/4 depicted right over here. You could view this entire bar as a whole, and we see that it is divided into 4 equal sections, and that 3 of them are shaded in. So those 3 that are shaded in, those represent 3/4 of the whole. So you see that right over there. And then this bar down here, you could view this as another whole. This is another whole right over here, and you can see this divided into 8 equal pieces, and 5 of them are shaded in. So that represents the 5/8. So we want to have 3/4, this green shaded area, and we want to take away the 5/8. So how could we do it? And even when you look at it visually, it might jump out at you. Whenever we add or subtract fractions, we like to think in terms of having the same denominator. Are we going to deal in fourths or eighths or sixteenths or whatever else? So let's think about having a common denominator. And a good common denominator is going to be a common multiple of the 2 denominators right over here, and ideally their least common multiple. And one way that I like to tackle that, there's many ways to do it, is look at the larger of the 2 denominators, look at 8, and then keep looking at increasing multiples of 8 until you find one that's also divisible by 4, perfectly divisible by 4. But with 8, you immediately say, well, 8 is divisible by 4, and it's clearly divisible by itself as well, so 8 is actually the least common multiple of 4 and 8. So you can rewrite both of these fractions as something over 8. So the 3/4, you can write it as something over 8, and then subtracting from that, the 5/8, if you want to write that as something over 8, well, that's just going to be 5/8. And then you can figure out your actual answer. So how can we rewrite 3/4 as something over 8? Well, there's a couple of ways to think about doing it. One way, look, I had 4 in the denominator. Now I'm going to have twice as many equal sections. I multiplied by 2, so I'm going to have twice as many of the sections actually shaded in. So times 2, 3/4 is the same thing as 6/8. And we can also see that visually. If we're going to have twice as many equal sections, here we have everything in fourths, but I'm going to turn this into twice as many equal sections, so I have 8ths. So let's do that. So you have this right here. Let me divide that. Let me divide that. Let me divide that. And then let me divide that. And now I went from fourths to 8ths. I have 1, 2, 3, 4, 5, 6, 7, 8 equal sections. And we see that 6 of them are shaded in. That 3/4 is the same thing as 6/8. But regardless, now we can subtract. We have 6/8, and we want to take away 5 of the 8ths. So we have 6/8, and we want to take away 1, 2, 3, 4, 5 of them. And those 5 of them correspond to these purple 5 right over here. We're taking away 1, 2, 3, 4, 5. We're taking these away. So if you're just looking at the green, we started with 6/8. We're taking away 1, 2, 3, 4, 5 of them. That looks, and you can see that corresponds to the 5/8 down here. And what are you left with? Well, you're just going to be left with this 1/8 right over there. So it's just going to be 1/8. And you could see that numerically up here. If I have 6 of something, in this case it's 6/8, and I'm going to subtract 5 of that something, in this case 5/8, I'm going to be left with 1 of that something, or 1/8.
It's true. Adding fractions with the like numbers.
Let's say that we have the fraction 9/10, and I want to add to that the fraction 1/6. 1/6. What is this? What is this going to equal? So when you first look at this, you say, oh, wait, I have different denominators here. It's not obvious how I add these. And you'd be right. And the way to actually move forward is to find a common denominator, to convert both of these fractions into fractions that have a common denominator. So how do you think about a common denominator? Well, a common denominator is going to have to be a common multiple of these two denominators, of 10 and 6. So what's a common multiple of 10 and 6? And it's usually simplest to find the least common multiple. And a good way of doing that is start with the larger denominator here, 10, and say, okay, is 10 divisible by 6? No. Okay, no. Is 20 divisible by 6? No. Is 30 divisible by 6? Yes. 30 is divisible by 6. So I'm just going through the multiples of 10 and saying, well, what is the smallest multiple of 10 that is divisible by 6? And that's going to be 30. So I can rewrite both of these fractions as something over 30. So 9 over 10, how would I write that as something over 30? Well, I multiplied the denominator. I'm multiplying the denominator by 3. So I've just multiplied the denominator by 3. So if I don't want to change the value of the fraction, I have to do the same thing to the numerator. I have to multiply that by 3 as well. Because now I'm just multiplying the numerator by 3 and the denominator by 3, and that doesn't change the value of the fraction. So 9 times 3 is 27. So once again, 9/10 and 27/30 represent the same number. I've just written it now with the denominator of 30. And that's useful because I can also write 1/6 with the denominator of 30. Let's do that. So 1/6 is what over 30? And I encourage you to pause the video and try to think about it. So what did we do to go from 6 to 30? We had to multiply by 5. So if we multiply the denominator by 5, we have to multiply the numerator by 5 as well. So 1 times 5, 1 times 5 is 5. So 9/10 is the same thing as 27/30, and 1/6 is the same thing as 5/30. And now we can add. And it's fairly straightforward. We have a certain number of 30ths added to another number of 30ths. So 27/30 plus 5/30. Well, that's going to be 27. That's going to be 27 plus 5 plus 5 plus 5/30. Plus 5/30, which of course is going to be equal to, what is this? 32/30. 32 over 30. And if we want, we could try to reduce this fraction. We have a common factor of 32 and 30. They're both divisible by, they're both divisible by 2. So if we divide the numerator and the denominator by 2, numerator divided by 2 is 16. Denominator divided by 2 is 15. So this is the same thing as 16/15. And if I wanted to write this as a mixed number, 15 goes into 16 one time with the remainder 1. So this is the same thing as 1 and 1/15. Let's do another example. Let's say that we wanted to add 1/2 to 11/12. To 11 over 12. And I encourage you to pause the video and see if you can work this out. Well, like we saw before, we want to find a common denominator. If these had the same denominator, we could just add them immediately. But we want to find a common denominator because right now they're not the same. Well, what we want to find is a common multiple of 2 and 12. And ideally, we'll find the lowest common multiple of 2 and 12. And just like we did before, let's start with the larger of the two numbers, 12. And we could just say, well, 12 times 1 is 12, so that you could view that as the lowest multiple of 12. And is that divisible by 2? Yeah, sure. 12 is divisible by 2. So 12 is actually the least common multiple of 2 and 12. So we could write both of these fractions as something over 12. So 1/2 is what over 12? Well, to go from 2 to 12, you multiply by 6. So we'll also multiply the numerator by 6. And we see 1/2 and 6/12. These are the same thing. 1 is half of 2. 6 is half of 12. And how would we write 11/12 as something over 12? Well, it's already written as something over 12. 11/12 already has 12 in the denominator, so we don't have to change that. 11/12, and now we're ready to add. So this is going to be equal to 6. This is going to be equal to 6 plus 11. 6 plus 11 over 12. Over 12. We have 6/12 plus 11/12 is going to be 6 plus 11 over 12, which is equal to 6 plus 11 is 17/12. If we want to write it as a mixed number, that is what? 12 goes into 17 one time with the remainder 5. So 1 and 5 over 12.
Yeah.
Let's do one more of these. This is strangely
fun. Yeah.
All right.
Strangely fun.
Let's say that we wanted to add. We're going to add 3/4 to. We're going to add 3/4 to 1/5. To 1 over 5. What is this going to be? And once again, pause the video and see if you can work it out. Well, we have different denominators here, and we want to find this. We want to rewrite these so they have the same denominator. So we have to find a common multiple, ideally the least common multiple. So what's the least common multiple of 4 and 5? We'll start with the larger number, and let's look at its multiples and keep increasing them until we get one that's divisible by 4.
No,
So 5 is not divisible by 4. 10 is not divisible by 4. Or perfectly divisible by 4 is what we care about. 15 is not perfectly divisible by 4. 20 is divisible by 4. In fact, that is 5 times 4. That is 20. So what we could do is we could write both of these fractions as having 20 in the denominator, or 20 as a denominator.
15
so we could write 3/4 is something over 20. So to go from 4 to 20 in the denominator, we multiplied by 5. So we also do that to the numerator. We multiplied 3 times 5 to get 15. All I did, to go from 4 to 20, multiply by 5, so I have to do the same thing to the numerator. 3 times 5 is 15. 3/4 is the same thing as 15/20. And over here, 1/5, what is that over 20? Well, to go from 5 to 20, you have to multiply by 4. So I have to do the same thing in the numerator. I have to multiply this numerator times 4 to get 4/20. So now I've rewritten this. Instead of 3/4 plus 1/5, it's now written as 15/20 plus 4/20. And what is that going to be? Well, that's going to be 15 plus 4 is 19/20. 19/20. And we're done.
Awesome, Sal. Amazing. So, subtracting fractions with unlike denominators.
Let's see if we can figure out what 4/3.
I don't even know if we're recording. Like, you've been saying that.
Minus.
I'm real paranoid or something.
Minus 1/5 is. And if you think you know how to do it, I encourage you to pause the video and give it a go. So when you first look at this, the thing that might jump out at you is we have different denominators here. And so it's not obvious how to subtract 1/5 from 4/3 when you have these different denominators. And the key is to rewrite each of these fractions so that they have the same denominator. And how do we figure out what that same denominator is? Well, it's going to be a common multiple of 3 and 5. And ideally, it's going to be the least common multiple of 3 and 5. So how can we calculate that? Well, we can start with the larger of the two numbers, say 5, and let's go through its multiples and see when we get to one that's divisible perfectly by 3. So 5 is not divisible by 3, 10 is not divisible by 3, 15 is divisible by 3. In fact, 15 is 3 times 5. So I can rewrite both of these fractions as something over 15. So what's 4/3 if I were to write it as something over 15?
20 over 15.
Well, to get from 3 to 15 in the denominator, we have to multiply
by 5.
We have to multiply by 5. So if you multiply the denominator by 5, if you don't want to change the value of the fraction, you have to multiply the numerator by 5 as well.
Yeah.
So you have to multiply the numerator by 5 as well. 4 times 5 is going to be 20. So 4/3 is the same thing as 20/15ths. All right. Now how would we rewrite 1/5 as something over 15? So we're going to have 15 in the denominator. Well, to go from 5 to 15, we have to multiply by 3. So if we multiply the denominator by 3, we have to multiply the numerator by 3 as well. So times 3. 1 times 3 is just 3. So 4/3 minus 1/5, we can rewrite that as 20/15 minus 3/15. And now this becomes a lot more straightforward. What is this going to be? Well, this is going to be a certain number of 15ths. We have 20 15ths, and we're taking away 3 of those 15ths. So we are going to have, if you have 20 of something and you take away 3 of them, you're going to have 17 of those things. In this case, we're talking about 15ths. So this is going to be 17 15ths. And if we wanted to write it as a mixed number, we could say 15 goes into 17 one time with a remainder 2. So it's 1 and 2 15ths. Let's do another example. Let's see if we can figure out. Let's see if we can figure out what 7 tenths minus 5/8 is. 5/8. And I encourage you to pause this video and see if you can calculate it yourself.
So this is going to be 40.
Well, just like we saw before, we have different denominators, but we need to rewrite them so that they have a common denominator. That way we can subtract. And so what's a common multiple of 10 and 8? And ideally the least common multiple. It doesn't have to be, but it keeps things a little bit simpler. Well, let's start with the larger of the two numbers. And then keep finding their multiples and find one that is perfectly divisible by the other one, by 8. So 10 isn't perfectly divisible by 8. 20 isn't. 30 isn't. 40 is. 40 is a multiple of 10, and it's a multiple of 8. In fact, it's the least common multiple of 10 and 8. So we can rewrite both of these fractions as something over 40. So that's going to be something over 40 minus something over 40. Minus something over 40 is equal to something. So 7 tenths is what over 40? Well, to go from 10 to 40 in the denominator, we multiplied by 4. So we have to do the same thing in the numerator. Multiply the numerator by 4. 7 times 4 is 28. So 7 tenths is the same thing as 28 40ths. And now let's do the same thing with the other fraction. To go from 8 to 40 in the denominator, we had to multiply the denominator by 5. 8 times 5 is 40. So if we multiply the denominator by 5, we have to multiply the numerator by 5 as well. 5 times 5 is 25. So 7 tenths minus 5/8 is the exact same thing as 28 40ths minus 25 40ths. And now this makes a lot of sense. It's going to be a certain number of 40ths. If I have 28 40ths and I take away 25 of those 40ths, how many 40ths am I going to have left? Well, I'm going to have 3 40ths left. 28 40ths minus 25 40ths. So I'm going to have 3 40ths. 28 minus 25 is 3. And we are done. 7 tenths minus 5/8 is 3 40ths.
4/4. Oh, we're going to do the activity now, okay? 6 minutes. 4 questions. Okay, it's going to be 2/4, right? Oh shit, I could be wrong. It should be 3/4. Whoa, the hell? Subtract. Okay, 1/2. So, oh shit, it's in 14 for both these guys. Okay, so let's write stuff. 7, 14, and we have 14. 6, and we have 1, 14. Wow, okay. 2 plus 2, 14. Wait. No, it's not 2. It's not 2, dude. This is 7. Wait, what? 2 times 7 is 14. 14. Wait, 7. 9. So I guess this is gonna be 4/6 and minus 1. We have 3/6 or 1/2. 1/2. Cool. Let's go. Okay, it's gonna be by 3, right? So 13/12. Okay. You have 15 over 8. Holy crap. It's come 24, right? So for that, we move over 4, we have 16. 16 for the top part, and then 3, 12, 12, 28, 24. Oh shit, I could have simplified it, but okay. It's 12. So we have 21. 21 plus 8, we have 29. 12. Oh shit, that was slow. One half plus 8 pounds. Okay, so we're gonna multiply by 6. So 14 pounds. Man, I could have simplified it even further. Then we have 6 times 5, 15, 21, 21 over 10. Oh crap, this is hard. 24, 3, okay. Be 10 plus 6. Man, I should simplify. Okay, so this one's 9, 18, 9, 8, right? 6, 12, 24 on the denominator. So it's gonna be 432 minus, let's write this. 32 minus 329, 29 over 24. Common multiple is going to be 12. So 12, 8, 16 plus 3, 15. Oh shit, it's minus. So we have 1 over 4. Okay, so oh shit, it's going to be 60. 12 by 5. Okay, so it's going to be 45. 4/5 to become 60. You're gonna have 212. So holy shit. 12, 48. Wow. 3 or 16. It's gonna be 15. No, not 15. It's actually 20 minus 12. 8 and 4 plus 4 12s. 6, 2, 1, 3rd. Wow, I simplified now. Okay. So this one's gonna be 21 minus 7. Oh my god, I don't even know. I think that's 14. 14 over 6. Could be wrong. Yeah, I guess that's the answer to this pair. Oh shit, it's gonna be 60 as well. Times 5, we have 30. We're that from 60 over 6. 3, 6, 18. And what's this gonna be? From minus by 20, it's gonna be 10. Let's do it. Well, 12 over 60 could be 30 and 6. Yeah, I think it's gonna be 1/5. Awesome, awesome. Okay, next. Gonna grab a drink. Gonna close a bit. Alright, I'm back. Adding and subtracting mixed numbers with unlike denominators.
Let's add 19 and 3/18
Running, recording, running time. 30 minutes in. All right,
to
let's go.
18 and 2/3. So I like to separate out the whole number parts from the fraction parts. So 19 and 3/18 is the same thing as 19 plus 3/18. And to that, we are going to add 18 and 2/3, which is the same thing as 18 plus 2/3. Now we can separately add the whole number parts. So we could add the 19 to the 18. So we could do 19 plus 18. And then we can add the fraction parts. Plus 3, let me do this in green, plus 3/18, plus 3/18, plus 2/3, plus 2/3. Now 19/18, pretty straightforward. That is what? Let's see, 19 plus 19 would be 38, so this is going to be one less than that. It's going to be 37. So that gives me 37. And then 3/18 plus 2/3, to add them I need to have the same denominator. And the least common multiple of 18 and 3 is 18. So let's convert 2/3 to something over 18. So 2/3, if I want to write it as something over 18, well, I multiply the denominator by 6, so I'd also have to multiply the numerator by 6. So it's the same thing as 12/18. So I can rewrite 2/3 as 12/18. And now I can add these two things together. That's going to be, so I have 37 plus, it's going to be something over 18, plus something over 18. 3 plus 12 is 15, plus 15/18. And so expressing this as a mixed number, I get 37 and 15/18. And that's the right number, but we can simplify it even more. We can simplify the 15/18. Both the numerator and the denominator are divisible by 3. So let's divide them both by 3. And we're not changing the value because we're doing the same thing to the numerator and the denominator. And so this gives us, we still have our 37. We still have our 37, but the numerator is now 5, and the denominator is now 6. So we get 37 and 5, 6. 37 and 5, 6. And we're done. Let's try to evaluate 7 and 6/9 minus 3 and 2/5. So like always, I like to separate out the whole number parts from the fractional parts. This is the same thing as 7 plus 6/9 minus 3 minus 2/5. And the reason why I'm saying minus 3 minus 2/5 is this is the same thing as minus 3 plus 2/5. And so you distribute the negative sign. You're subtracting a 3, and then you're subtracting the 2/5. And so now we can worry about the whole number parts. 7 minus 3. Well, 7 minus 3 is going to give us 4. So that's going to give us 4. And then we're going to have 6/9 minus 2/5. So let me think about what 6/9 minus 2/5 are.
Yeah,
6/9 minus 2/5. Well, we're going to have to find a common denominator. So this is going to be the same thing. And I think the least common multiple of 9 and 5 is going to be 45. Literally, them multiplied. They have no common factors. So it's going to be over 45. They go from 9 to 45 to multiply by 5. So I'm going to have to multiply the numerator by 5. So 6 times 5 is 30. And then I'm going to subtract. To go from 5 to 45, I had to multiply by 9. So I have to multiply the numerator by 9 if I don't want to change the value. So 2 times 9 is 18. And 30 45ths minus 18 45ths is going to be something over 45. 30 minus 18 is 12. So this is, if I subtract these two fractions right over here, I get 12 45ths. So it's 4 plus 12 45ths. Or if we wanted to write it as a mixed number, this is equal to 4 and 12 45ths. But we're not done yet. We can simplify this further. 12 and 45 have common factors. They are both divisible by 3. They're both divisible by 3. So we can say that this is, actually they're both divisible by, yep, well I think we can divide more after that. So let's see, if we divide the numerator by 3 and the denominator by 3, we end up with 4, and 12 divided by 3 is 4, and 45 divided by 3 is 15. 4 and 4/15. And actually, we're done. These two can't be simplified anymore. 4 and 4/15. So we have here 2 and 2/3 plus 8 and 3/4. And I encourage you to pause the video and see if you can compute what this is. So now let's work through this together. And there's a bunch of ways that you can tackle this. I'll do it in a couple of different ways. So one way that you might see is to just rewrite this expression. To just rewrite 2 and 2/3 plus 8 and 3/4 plus 8 and 3/4. And you might be saying, why would I rewrite it this way?
10 and 7.
Well, when you rewrite it this way, it's very clear that these are the fraction parts of the mixed numbers, and these are the whole number parts of the mixed numbers, and maybe we can add them separately. But before we even start adding the fraction parts of the mixed numbers, we notice that we have different denominators here. We have a 3 and we have a 4. So it would be nice to find a common denominator. And we've seen multiple times in the past when you're adding fractions with unlike denominators, a good common denominator would be their least common multiple, the least common multiple of 3 and 4. Well, what's that going to be? Well, let's look at the multiples of 4. 4 is not perfectly divisible by 3. 8 is not perfectly divisible by 3. 12 is. In fact, 12 is 4 times 3. So I can rewrite both of these fraction parts with 12 as their denominator. So this is going to be equal to, let me just write it this way. So I can rewrite it as 2 and something over 12. Now, what would be that something over 12? To go from 3 to 12 in the denominator, we multiply by 4. So we have to multiply the numerator by 4 as well. So 2 times 4 is 8. 2/3 is the same thing as 8/12. So 2 and 2/3 is the same thing as 2 and 8/12. And then we could do the same thing down here. 8 and 3/4 is going to be the same thing as 8 and something over 12. Well, to go from 4 to 12 in the denominator, you multiply by 3. So we have to multiply the numerator by 3 as well. 3 times 3 is 9. And now we can add. And what do we get? Well, we have 8/12 plus 9/12. That's going to be 17 12. Well, you might recognize 17/12. This is greater than or equal to 1. So we could actually, this is an improper fraction right over here. So we can actually rewrite this. We can rewrite this as a mixed number. Let me make it clear. 17/12. So do it right over here. 17 over 12 is the same thing as 1 and 5/12. How did I figure that out? 12 goes into 17 one time, and then I still have 5 left over. 17/12 is the same thing as 1 and 5/12. So what I could do is I could write the 5/12 part in the fraction part of our, or I guess the fraction place on our numbers, and then I can regroup the 1, put it in the whole number column. And now I can just add the 1 plus 2 is 3 plus 8 is 11. So we get 11 and 5/12. 11 and 5/12. Now there's other ways that we could have tackled this. What we could have done is gone from this place right over here, the 2 and 8/12 and the 8 and 9/12, and we could have converted these into improper fractions, then added those improper fractions. So we could have said that this is the same thing. Let me rewrite it.
Oh shit, it's insane.
Yeah. 2 is the same thing as 24/12 plus 8 is going to be 32/12. So I could rewrite this top mixed number as 32 over 12, clearly an improper fraction. And I could rewrite this bottom mixed number as, let's see, 8 is how many 12ths? That's going to be 96/12 plus another 9/12 is 105/12. 105/12. If what I just did looks a little bit confusing, you should review the Khan Academy videos on converting mixed numbers to improper fractions or vice versa. But now I could think about adding these two. And what would I get? I would get 32/12 plus 105/12, which would be what, 137/12. And then if we wanted to rewrite this as a mixed number, we could say, okay, let's see, 12 will go into 137 11 times. So it goes 11 times. 11 times 12 is 132, so you would have 5 left over. So it's 11 and 5/12. So you could have done it either way. I think this one would, the way we did it the first time would have been a little bit easier because you didn't have to deal with these really big numbers like 137 and 105 and 32, and you just dealt with more straightforward numbers. Say, hey, look, 8 twelfths plus 9 twelfths is 17 twelfths, which is the same thing as 1 and 5 twelfths. And then you add 1 and 5 twelfths plus 2 plus 8 is going to give you 11 and 5 twelfths. So we have the expression 17 and 4/9 minus 12 and 2/3. And I encourage you to pause the video and see if you can figure out what this is. So now let's work through it. So what I'm going to do is I'm going to rewrite these mixed numbers. So I'm going to write this as 17 and 4/9 minus 12 and 2/3.
4/9 minus it's gonna be. Dude's gonna borrow from 17, I guess. We're gonna have like, instead of 9, we're gonna have 14, and then 17 is gonna be 16, then it's gonna be 16, 4.
2/3. I'm going to write the 12 right under the 17, and I'm going to write the 2/3 right under the 4/9.
4 and
clear. We are subtracting 12
9.
and 2/3 from 17 and 4/9. So the first thing that we might want to do is we could look at the fraction parts, and we might want to start subtracting until we see, look, we have different denominators here. We have ninths and we have thirds. So the first thing we'd want to do is let's get to a common denominator. And a good common denominator would be the least common multiple of 9 and 3. Well, what's that going to be? Well, to think about that, I like to start with the larger number, 9, and say, well, is that divisible by 3? Well, yes, it is divisible by 3. It is divisible by the other denominator. So this actually is the least common multiple. If it wasn't, I would keep taking higher and higher multiples of 9. I'd go to 18, and then I would go to 27. And I would keep going until I found one that's divisible by 3. But I didn't have to do that because 9 is divisible by 3. So I can rewrite both of these fraction parts as in terms of ninths. Now the one on top already is written in terms of ninths, so I can just rewrite that. 17 and 4/9. And the one on the bottom I can write as 12 and some number of ninths. So 2/3 is how many ninths? Well, to go from thirds to ninths, I had to multiply by 3. I had to multiply by 3. So the numerator I need to multiply by 3 as well. 2 times 3 is 6. 2/3 is the same thing as 6/9. And now I can try to subtract. But even here, when I try to subtract, I have a larger fraction down here that I'm trying to subtract from a smaller one. I have 4/9 minus 6/9. So what can I do? Well, the answer is I can regroup. I can take a whole from the 17. Let me do that. So if I take a whole from the 17, that's going to become 16. And then that whole that I just took from, as you can say, the whole number place, I can add it to the fraction. Well, a whole is just going to be 9/9. So all I did is I regrouped here. I took 9/9 from 17. 9/9 is 1. So I took 9/9 from 17. I'm left with 16. And then I regrouped them and I added them to the fractions place is one way to think about it. Well, what's 4/9 plus 9/9? Well, that's going to be 13/9. So this right over here is 13/9. 13/9. It's a very strange way to write it, but 17 and 4/9 is the same thing as 16 and 13/9. Notice this is greater than 1. This is the same thing as 1 and 4/9. 1 and 4/9 plus 16 is going to be 17 and 4/9. Now, why did I do all of this? Well, 13/9 is larger than 6/9, so I can subtract. What's 13/9 minus 6/9 going to be?
7/9.
Well, 13 of something, in this case ninths, minus 6 of that same something is going to be 7/9. 7. Let me write that in a neutral color. So that's going to be 7/9. 13/9 minus 6/9 is 7/9. And then I can look over in the whole number place. All I have left is 16 here. 16 minus 12 is 4. And I'm done. 17 and 4/9 minus 12 and 2/3 is equal to 4 and 7/9.
Cool. It's gonna be 10 6, 9, 10. Five, 10, 6, 3 tenths. Okay. So 4 and oh shit, it's gonna be 24, 8, 16, 24, yeah. For that would be 9. And then for that to be 4, you have to multiply by 8. 8, 9, 7, 4, 17, 4. Okay, so 3, 10, 20. That's going to be 8 minus 5. 3, 8, okay, so this one's with regrouping. It's going to be hard. This is going to be hard. Okay, let's see. Oh, this is plus. Add and subtract. Okay. So 6, 12, 1. We have 3, 12, 10 plus 12. 4, we have 14. So 3, 4, and 2 12s, 4, 1, 6. Okay. Subtract. 2, 9. 18. 12, 18. Okay. So 4, 18 minus 18, 15. Then we're gonna grab 1. Becomes 6. Then 4 plus 9 is gonna be 13. Oh shit, wait, what? It's by 18. Did he do the... We're already at 18. Okay, so it's gonna be 18. So plus 18. So if we have 4, then plus 18. Like, wait, what? 4, 18, 22, 7, 18. So we have 6 and then minus 3 with 3, and we have 7, 18. I think this is correct. Okay, the adding is much easier. So we have 10, 6 plus 10, 5. We have 11. 10 or 1 over 10 is 1. 7, 8, 12 over 12 and 1. Okay, let's go. Subtract this. Okay, so 4 9s, it's good. Minus 9. 3, 6 over 9. Then 9, say 13. And 70 is going to be... Hey, wait, this is the same as the video. So we have 4 and 7 9s. Adding and subtracting fractions is word problems. Oh, word problems are so hard, man.
Pedro is supposed to practice piano for 3/4 of an hour every day. Today he has practiced for 1/4 of an hour. What fraction of an hour does he need to practice? So let's visualize 3/4. So he needs to practice 3/4 of an hour. So if this represents an entire hour, so this represents an entire hour. So let's divide it into fourths. So now divide it into halves. Now let's make it into 4 equal section. Now it's into fourths. So he needs to practice. So he needs to practice 3/4 of an hour. So he needs to practice 3/4 of an hour. That was my attempt at drawing an arrow. So let me shade it in. So he needs to practice 3/4 of an hour. This gets us to 3/4 right over here. So he needs to practice 3 out of the fourths of an hour. So this is 3/4. Now it says he has already practiced for 1/4 of an hour. So he's already practiced for 1/4. 1/4. So how much more does he need to practice? How much more does he need to practice? Well, he needs to practice this much more. He needs to practice this much more, and you might already see the answer visually, but let's think about how to represent it as a fraction expression. So let me write it like this. So this is how much he needs to go. How much does he need to practice? So he needs to do a total of 3/4. He's already done 1/4. He's already done 1/4. So if you subtract 1/4 from the 3/4, you're going to get this amount right over here. You're going to get the amount that he needs to practice. Now, this already has the same denominator, so this is going to be equal to 3 minus 1 over 4. 3 minus 1 over 4, which is equal to 2/4. And you see that right over there. He still needs to practice 1 and 2 out of the fourths, 2/4. Now, 2/4 we know is the same thing as 1/2. There's a couple of ways to think about it. You could say, hey, look, this is half of the length of this entire thing. It has a little bit on this end and that end. Or if you made 4 blocks like this, if you make 4 blocks, if you make 4 equal blocks, and if you were to shade in 2 of them, you see that you have shaded in 1/2 of the blocks. This is the exact same amount as if I just divided into 2 sections and I shaded in only one of them. 2/4 is equal to 1/2, is the same thing as 1/2. And if you wanted to work it out mathematically, you just have to do the same thing to the numerator and the denominator. So let's divide the numerator and the denominator by 2 because they are both divisible by 2. That's actually their greatest common factor. So 2 divided by 2 is 1, 4 divided by 2 is 2. So what fraction of an hour does he need to practice? He's got to practice half an hour. James and Carly caught a lizard in their backyard. Its body is 17/8 inches long. Its tail is 10/8 inches long. What is the length of the lizard's body and tail together? So good thing we have the lizard obediently standing next to our measuring stick or our ruler or whatever this happens to be, and we have it marked off in inches. And not only that, we have it marked off in 1/8 of inches. Notice this is an inch, and we have 1, 2, 3, 4, 5, 6, 7, 8 sections of that actual inch. So let's see, 17/8 inches long. This is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This right over here is 17/8. 17/8, which you might notice is also equal to 2 1/8. 8 goes into 17 2 times with a remainder of 1. But we won't talk about that just yet. But we see that's the length of the lizard's body. 17/8. I just counted off 17 of these 8s right over here. 17/8. And then they say that the tail is 10/8 inches long. The tail is 10/8 inches long. So it's another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this distance right over here, I just counted off 10/8. So that's another 10/8 inches long. And it gets us all the way to the end of the lizard's tail. And they say, what is the length of the lizard's body and tail together? Well, that's going to be the length of the body plus the length of the tail. So you have 17/8 plus 10/8. Well, that's going to get you to 17 plus 10/8. 17 plus 10/8, which is equal to 27. 27 over 8. And so this mark right over here is 27 over 8. And if you wanted to write this as a mixed number, you could just say, well, 8 goes into 27 3 times, and you have a remainder of 3. So this is equal to 3 3/8. And you see that on the ruler right over here. It's equal to 1, 2, 3, and then we have another 1, 2, 3/8. These two things are equivalent. Cindy and Michael need 1 gallon of orange paint for the giant cardboard pumpkin they are making for Halloween. Cindy has 2/5 of a gallon of red paint. Michael has got half a gallon of yellow paint. If they mix their paints together, will they have the 1 gallon they need? So let's think about that. We're going to add the 2/5 of red paint, and we're going to add that to, or 2/5 of a gallon of red paint, and we're going to add that to half a gallon of yellow paint. And we want to see if this gets to being 1 whole gallon. So whenever we add fractions, right over here, we're not adding the same thing. Here we're adding 2/5. Here we're adding 1/2. So in order to be able to add these two things, we need to get to a common denominator. And the common denominator, or the best common denominator to use, is the number that is the smallest multiple of both 5 and 2. And since 5 and 2 are both prime numbers, the smallest number is just going to be their product. 10 is the smallest number that we can think of that is divisible by both 5 and 2. So let's rewrite each of these fractions with 10 as a denominator. So with 10 as a denominator. So 2/5 is going to be something over 10, and 1/2 is going to be something over 10. And to help us visualize this, let me draw a grid. Let me draw a grid with tenths in it. So that's that, and that's that right over here. So each of these are in tenths. These are 10 equal segments this bar is divided into. So let's try to visualize what 2/5 looks like on this bar. Well, if we were to divide, right now it's divided into tenths. If we were to divide this bar into fifths, then we're going to have, so that's 1, actually let me do it in that same color. So it's going to be, so this is 1 division, 2, 3, 4. So notice, if you go between the red marks, you are going, these are each a fifth of the bar. If you go between the red marks, and we have 2 of them. So we're going to go 1 and 2. This right over here, this part of the bar represents 2/5 of it. Now let's do the same thing for 1/2. So let's divide this bar exactly in half. So exactly in half. So let me do that. So divide it exactly in half. And 1/2 literally represents one of the 2 equal sections. So this is 1/2. Now, to go from fifths to tenths, you're essentially taking each of the equal sections and you are multiplying by 2. So to go from fifths to tenths, you're multiplying by 2. You had 5 equal sections, you split each of those into 2, so you have twice as many, and you now have 10 equal sections. So those 2 sections that were shaded in, well, you were going to multiply by 2 the same way. Those 2 are going to turn into 4 tenths. 4 tenths. And you see it right over here when we shaded it initially. If you look at the tenths, you have 1 tenth, 2 tenths, 3 tenths, and 4 tenths. Let's do the same logic over here. If you have 2 halves and you want to make them into 10 tenths, you have to take each of the halves and split them into 5 sections. You're going to have 5 times as many sections. So to go from 2 to 10, we multiply by 5. So similarly, that 1 shaded in section, that in yellow, that's going to turn into 5. That 1/2 is going to turn into 5 tenths. So we're going to multiply by 5. Another way to think about it, whatever we did to the numerator, or whatever we did to the denominator, we have to do to the numerator. Whatever we did to the denominator, we have to do to the numerator. Otherwise, we're changing the value of the fraction. So 1 times 5 is going to get you to 5. And you see that over here when we shaded it in. That 1/2, if you look at the tenths, is equal to 1, 2, 3, 4, 5 tenths. And now we are ready to add. Now we are ready to add these two things. 4 tenths plus 5 tenths. Well, this is going to be equal to a certain number of tenths. It's going to be equal to a certain number of tenths. It's going to be equal to 4 plus 5 tenths. 4 plus 5. 4 plus 5 tenths. And we can once again visualize that. Let me draw our grid again. So 4 plus 5 tenths. I'll do it actually on top of the paint can right over here. So let me color in 4 tenths. So 1, 2, 3, 4. and then let me color in the 5/10. And notice that was exactly the 4/10 here, which is exactly the 2/5. Let me color in the 5/10. 1, 2, 3, 4, and 5. And so how many total tenths do we have? We have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of the tenths are now shaded in. We had 9/10 of a gallon of paint. So now to answer their question, will they have the gallon they need? No, they have less than a whole. A gallon would be 10/10. They only have 9/10. So no, they do not have enough of a gallon.
Sad.
Now another way you could have thought about this, you could have said, hey look, 2/5 is less than a half. And you could even visualize that right over here. So I have something less than a half plus a half, I'm not going to get a whole. So either way you could think about it, but this way at least we can think it through with actually adding the fractions.
Tomatoes.
Sylvia is growing tomato plants and studying their heights. Here is her data. So the beefsteak tomato type had a height of 3 1/4 feet, Roma 2 7/8 feet, cherry 3 1/2 feet. And they ask us, what is the difference between the heights of the beefsteak, so that's that one right over there, and the Roma tomato plants. So they want us to find the distance between these two heights. So this cherry tomato height, this was really unnecessary for the sake of this problem. So we want to find the difference in these two heights. So we want to subtract the smaller of these from the larger of these. So we're really trying to evaluate what 3 and 1/4 minus 2 and 7/8 is. Minus 2 and 7/8. Now, the first thing that I like to do is convert both of these into mixed numbers. So let's, they're already mixed numbers, to convert both of these into improper fractions. So 3 and 1/4 is the same thing as 3 plus 1/4, which is the same thing as 12 fourths plus 1/4. That's the same thing as 3 and 1/4. And from that, we're going to subtract 2 and 7/8. 2 and 7/8 is the same thing as 2 plus 7/8. 2 is the same thing as 16/8 plus 7/8. So this is essentially what we are trying to figure out. Now, what is 12 fourths plus 1/4? It's 13 fourths. 13/4. And then what's 16/8 plus 7/8? Well, that's 23/8. So this is going to be minus 23/8. Now we're subtracting one fraction from another, but we have different denominators, so we can't make sense of this until we have the same denominator. And so what is the least common multiple of these two denominators, of both 4 and 8? What is the smallest number that is divisible by both 4 and 8? Well, 8 is divisible by 8, and 8 is also divisible by 4. So if we can rewrite 13/4 as having 8 as a denominator, then we are all set. So let's try to do that. So we're going to write both of these as 8 with 8 as a denominator. This one already has it. So 13/4. So we're going to 4 as having 8 as a denominator, then 4. So if we can rewrite 13 divisible by 8, and 8 is also divisible by 4. So if we
divisible by 4, yeah.
can rewrite 13
Wait, what did it address?
over 4 as having 8 as a denominator, then we are all set. So let's try to do that. So we're going to write both of these as 8 with 8 as a denominator. This one already has it. So 13/4, I'm going to have it with 8 as a denominator. So if we multiplied the denominator, to get from 4 to 8, we have to multiply the denominator by 2. So in order to not change the value of the fraction, we have to multiply the numerator by that exact same value. We got to multiply it by 2. So this becomes 26/8. And from 26/8, we're going to subtract 23/8. And so this is going to be over 8, 26 minus 23, which is equal to, and we deserve our drum roll now, 26 minus 23 is 3.
Crap. Holy crap. Last thing that happened, we lost power, and my recording ended abruptly. And luckily, my recording didn't get corrupted or anything, so I tried to play it, and this is the part where I left off. So the time is 23:14. So yeah, it's 11:14, and now it's 11:39. So that much amount, the power time lost. And so yeah, this last thing, I'm eating my penciler.
Minus 23.
That's sort of weird, but
which is
yeah.
equal to, and we roll now, 26 minus 23.
So after
is
this one,
3.
we're gonna. Alright, I'll stop. Last thing, and then it's this video. And am I recording? Okay, great.
26
So it's this video, and then we're just gonna continue where I left off.
Minus 23, which is equal to, and we
Yeah.
deserve our drum roll now. 26
Great.
minus 23 is 3. So it's 3/8. So the difference between the heights of the beefsteak and Roma tomato plants, 3/8, and everything we've been doing insofar has been in feet. So 3/8 of a foot.
Man, I hate that I have to upload 2 videos. It should be one continuous long video. But okay. Dude, the voice, yeah. Okay, good. Tyler and Katie started the lemonade stand to raise money. They donated 2/10 of their profits to their school library. Oh, wait. The same denominator, subtraction, add, subtract. To this one. They donated 2/10 of their profits, 1/10 to the animal shelter, 4/10 to the food bank. They saved the rest to buy material. What fraction of their profits did Tyler and Katie donate? Okay, so donated 7/10. Wait, why did that end? Okay. They will show season Veronica ran on break. I don't need to know. I think it should be comparison of 2 things. Yeah, Tuesday and Friday. How many kilometers did Veronica run on Tuesday and Friday? So, Tuesday and Friday. Okay, so Tuesday 7. Okay, he ran 12 words. I think this should be just 3, right? Yeah. Okay. Together, Lulu, Jessica 8, 7, and Lulu 8. What fraction of the pizza did Jessica eat? Oh, so she ate 7/10. The child's ladder is made of 3 sections. Each section is 3/4 meter long. How long is the ladder when all 3 sections are extended to make one ladder? Wait, what? A child's ladder is made of 3 sections. Each section is... Oh, okay. So it's gonna be like 9/4. The table shows the distance Shannon ran over a week. Tuesday, Wednesday, Friday, Saturday. How many more kilometers did Shannon run on Friday than on Saturday? Friday, Saturday. So it's gonna be 2/1 or just 2, and then we have 1/2. Holy shit, this is insane. Let's just say 1/2 minus like 4 2 let's just say 3. Is correct? Oh shit. Okay. Perry is supposed to practice piano for 4/6 of an hour a day. Today he practiced for 2/6 of an hour. What fraction of an hour does still need to practice? Yo, we need to practice 2/6 more, man. Let's go. Heidi grew her hair out for many years. Her hair was 1/3 of a meter long. She donated her hair by cutting off 5/6 of a meter. Okay, so she has 1. Let's convert this into an improper fraction. So we have 1/3, 4, 3. Then we're gonna make the denominator the same. So we have 8 6, and we're gonna minus 5 from that, so we have 3/6 or 1/2 meter long. At the party, Aisha and her friends ate 2.5 pizzas. After the party, were 1 1/8 pizza left. How many pizzas were there at the start of the party? Wait, what? Oh, I'm gonna add these two guys. Okay. So we have 3, then like 4 eights. I'm gonna be 3 and 5 eighths. 2 lions, Floppy and Fireball met at the zoo. Floppy's tail is 1 1/3 of a meter long. Fireball's tail is 1 1/4 of a meter long. How much longer is Floppy's tail than Fireball's tail? Okay, so that's gonna be like 4/12 minus 3/4, and then I get 1/12. Mrs. Alvarez asked her class how many hours of TV they watch per day. The nearest half hour. The results are shown below. Fraction of the class. More than 3. What fraction of students watch between 0 and 2 hours of TV a day? Wait, what? Between 0 and 2 hours? Between 0 and 2. So there's 2 guys, right? So we're gonna add them. So 6, 12, 2, 7, 12. The class. Cool. Recording. Good. Start. Oh shit. Where's that? Okay. The results of an election are shown in the table below. What is the difference between the fractions of votes received by Dragovic Johnson? Dragovic and Johnson. Wait, my mind is wandering from something else. Okay, I should focus. Okay, so the results of an election are shown below in the table below. Fraction of votes 1978. Okay, what's the difference with fraction of votes received by Dragovic and Johnson? So the difference between Johnson and Dragovic. So clearly this guy is larger. Then their common denominator is going to be 18. So that's going to be 2 eighths, and then the other guy, let's put it over here since it's larger. So for that, it's 9. Oh shit, 18, then 9. So we have 7, 18. Add. Okay, so for the 8, we're going to 7, 8. Okay. 9, 16, 18, yeah. 18, 4 plus like 18 and 15. So, oh shit, this one's gonna have a group. A 19 over 18. So we have 14 and like 1/18, right? 2/3 minus 3/5. And both are like prime, so we're gonna have 15 times 5, we're gonna have 10 minus 15 times 3, we have 9. Okay, subtract 3/10 minus like 10/4. So it's gonna be 13, we have 14, we have 7, 10. But now 14. No way. No way. What the hell? Where did I go wrong? Where did I go wrong, man? Okay, so 3/10, and then we grab one of these guys. So we have gonna give 10 to this guy. So we have 13. Oh shit! Ah! Why did I 7 here? Ah, crap. Shouldn't be 7, should be 9. Wow, I'm an idiot. Did something level down? Oh man, I don't know. Okay, from between the quizzes. Okay, so nothing leveled down. I can try the quiz again. Jennifer used 2/7 of a meter of ribbon to make bows for her cousins. Now she has turned left. How much ribbon did Jennifer start with? What? Oh. Okay, so I'm gonna add the two guys. So this is not divisible by 7. This one's divisible by 7, but this one. This one. Oh shit! I'm not supposed to divide that. So we're gonna have like 21, 3, 6, plus 16, 21. Okay, let's add. We have 11 for the whole number side, and then holy shit, it's gonna be 12 times 3. We have times 2, 5, 10. We have 13 over 12, and then 4, 12, and wait, what? 1, 12 and 1. Oh shit, I don't want to mix it. I'm gonna restart this. Should be 12 and 1, 12, right? So it's gonna be like 8 over 12, 3 plus 12, 10, 13, 12. Give it the guy 1, 12. It's correct. Yeah. Okay. Add that guy. So 15 times 3. We have 6 plus 7. 7, 5, 13, 13, 15. Yo, what the fuck? Yo, oh. I'm making stupid mistake. I'm not thinking clear. Times 3 of 6 plus times 5. It's 11. Holy shit. Holy shit. I'm not thinking clear. I'm thinking of something else. I'm not focusing. Farmer George is painting 3 chicken coops. Start painting more now. He only has 1/3, 1 and 3/4 of a chicken coop left to paint this morning. Now he only has 1 and 3/4 of a chicken coop left to paint this morning. So we have 3 and like minus 1 and 3/4. This is the question, right? Okay. So if we convert this to like we're gonna have 7 over 4. Well, this 3 over here, like in terms of 4, that's gonna be like 12. Wait. Oh shit, I'm getting confused. So each 1 is equals to 4/4, and then like we have 3 of those, and you have now 14. 7/4. Holy shit, I'm not even sure. Wow, this is hard. Oh, because it should be like proper, right? Oh no, it's not. It's not even correct. Another shot. Okay. Spending 3 chicken coops. Starting now, he only has 1.13/4 of a Holy shit! This is hard. So you have 3, which we could say, we could, like that, right? This is 3, 12 by this is 3. Now it only has to 1. So I feel like we deduct, uh, like 4, 7. Yo, I'm getting stupid with math. Yo. Holy crap. I'm not thinking clear. Yo, I got 2 wrong. Nothing leveled down though. That's interesting. Okay, let's take a quiz again. These word problems are insane. The first team member in a 3-person relay race must run like... Okay. Not gonna fuck this one up. The first team member in a 3-person... What is a 3-person relay race? Must run 2 and 1/4 laps. And the second team member must run. How many laps in all must each team run? So I guess combination of all these guys. So 3 and 5/8 plus 2 and 8, 2 plus 1 and 8, 4, like times 4. So yeah, for the whole number, gonna add this guy. So we're gonna 9, 11, 11, 8, and then whole number parts of 6. Then we have to give it to this guy. So we have 7, 8, 3. Subtract. Okay, so we have 6 and 2 8s. We're gonna give another 8 to that guy. It'll be 5. So like we have 5, 8, and for the fraction part, and we have 5 minus 2, which would be 5 minus 2 equals to 2. Okay, so we're gonna add 2, 4, 5, 6. Plus 1/2. Okay. It's gonna be 4, 8, and then it's gonna be in total of 9 8s and 1 8, 5 and 1 8. Sylvia is growing trees and studying their heights. Her data is shown below. What's the difference between the heights of the birch and spruce trees? Height of the birch and the spruce trees. Difference, so 3 minus 2, 3 and 2 eighths minus the 2 and 7 eighths, right? So we're gonna borrow from this guy. We have 2, so this one's like cancels each other out, so we have only 8 and 10s minus 7 3 eighths, please. Thank you. So that's the quiz. Multiplying whole numbers and fractions. Whoa, this is gonna be insane.
We've already seen that the fraction 2/5, or fraction like the fraction 2/5, can be literally represented as 2 times 1/5. 2
Does my voice echo? Okay, not. Okay, cool.
times 1/5, which is the same thing, which is equal to literally having 2 1/5s. So 1/5 plus 1/5. And if we wanted to visualize it, let me make a hole here and divide it into 5 equal sections. And so this represents 2 of those fifths. This is the first of the fifths, and then this is the second of the fifths. Literally 2 fifths, 2 fifths, 2 fifths. Now let's think about something a little bit more interesting. What would 3 times 2 fifths represent? 3 times 2 fifths. And I encourage you to pause this video and based on what we just did here, think about what you think
6 fifths?
this would be equivalent to. Well,
Gonna
we
be
just
6 fifths,
saw
right?
that 2 fifths would be the same
2
thing as,
fifths
so let me
plus
just
2 fifths
rewrite
plus
this.
2
Instead of
fifths.
3 times 2 fifths written like this, let me write 2 fifths like that. So this is the same thing as 3 times 2 times 1 fifth. 3 times 2 times 1 fifth times 1 fifth. And multiplication, we could multiply the 2 times the 1 fifth first and then multiply by the 3. Or we could multiply the 3 times the 2 first and then multiply by the 1 fifth. So you could view this literally as being equal to...
What? 2 fifths. Why did he decompose 2 from the 2 fifths?
Instead of 3, saw that 2 fifths would be the same thing as, so let me just rewrite this as instead of 3 times 2 fifths written like this, let me write 2 fifths like that. So this is the same thing as 3 times 2 times 1 fifth. 3 times
okay.
2 times 1 fifth times 1 fifth. And multiplication, we could multiply the 2 times the 1 fifth first and then multiply by the 3. Or we can multiply the 3 times the 2 first and then multiply by the 1 fifth. So you could view this literally as being equal to
6 times
3
1
times
fifth.
2 is, of course, 6. So this is the same thing as 6 times 1 fifth. 6 times 1 fifth. And if we were to try to visualize that again, so that's a whole, that's another whole. Each of those wholes have been divided into 5 equal sections. And so we're going to color in 6 of them. So that's the first fifth, second fifth, third fifth, fourth fifth, fifth fifth, and that gets us to a whole. And then we have 6 fifths, just like that. So literally 3 times 2 fifths can be viewed as 6 fifths. And of course, 6 times 1 fifth or 2 6. So that's full second. And if we were to try to visualize that again, so that's a whole, same thing as 6. 3 times 2 is, of course, 6. So this is the same thing as 6 times 1 fifth. 6 times 1 fifth. And if we were to try to visualize that again, so that's a whole, that's another whole. Each of those wholes have been divided into 5 equal sections. And so we're going to color in 6 of them. So that's the first fifth, second fifth, third fifth, fourth fifth, fifth fifth, and that gets us to a whole, and then we have 6 fifths, just like that. So literally 3 times 2 fifths can be viewed as 6 fifths. And of course, 6 times 1 fifth or 6 fifths can be written as, so this is equal to literally 6, let me do the same color, 6 fifths, 6 over 5. Now you might have said, well, what if we, instead of viewing 2 fifths as this, as we just did in this example, we view 2 fifths as 1 fifth plus 1 fifth? What would happen then? Well, let's try it out. So 3 times 2 fifths, I'll rewrite it. 3 times 2 fifths, 2 over 5, 2 fifths, is the same thing as 3 times 1 fifth plus 1 fifth. 2 fifths is the same thing as 1 fifth plus 1 fifth. So 3 times 1 fifth plus 1 fifth, which would be equal to, well, I just have to have literally 3 of these added together. So it's going to be 1 fifth plus 1 fifth plus 1 fifth plus 1 fifth plus, I think you get the idea here, plus,
well, we could have just said
1
2 fifths in the first
plus
place.
1 fifth.
You're making this complicated.
Well, what's this
than
going
it
to be?
is.
Well, we literally have 6 fifths here. We could ignore the parentheses and just add all of these together. We once again have 1, 2, 3, 4, 5, 6 fifths. So once again, this is equal to 6/5. So
Damn,
hopefully
I
this
would have just
shows that when
written
you
2/5
multiply
plus 2/5
that
plus
2/5 we
2/5.
saw already represents 2 1/5. We already saw that, or 2 times 1/5. And 3 times 2/5 is literally the same thing as 3 times 2 times 1/5. Or in this case, that would be 6/5.
Equivalent fraction whole
So
number
we have here, it
multiplication
says
problem.
2 times 4/3 is equal to 8 times blank. And what I encourage you to do is pause the video right now and try to think about what should go in this blank.
Whoa, this is insane. 2 times 4/3 is equals to 8 times what? So 2 times 4/3, it's gonna be 8/3. So 1/3, I guess?
So I'm assuming you've given your try. Now let's think through this. So 2 times 4/3, we can literally view that as the same thing as, if we rewrite the 4/3, this is the same thing as 2 times, instead of writing 4/3 like this, I'm literally going to write it as 4/3. And I know it sounds like I just said the same thing over again, but I'm literally going to write 1/3 4 times. 1/3 plus 1/3 plus 1/3 plus 1/3. This is literally, if you call each of these a third, there you literally have 4 of them. This is 4/3. 2 times 4/3 is the same thing as 2 times literally 4/3. Now, what would this be? Well, this is going to be equal to, let me just copy and paste this. It's going to be this 2 times. So copy and then let me paste it. So that's one group of those 1/3 of those 4 1/3, or one group of one of these 4/3, and then we'll have another one. And then we'll have another one, and we're going to add them together. That's literally 2 times 4/3. So let's add these together. Now what do we have? Well, we have a bunch of thirds, and we need to count them up. We have 1, 2, 3, 4, 5, 6, 7, 8 thirds. This is literally equal to, and we could, just to make it clear what I've just done, we could ignore the parentheses and just add up all of these things together. So that might make it a little bit clearer. So let me do that. Just to make it clear that I literally I've taken 8 1/3 and I'm adding them together, which is the exact same thing as 8 thirds. So let me clear that. And let me clear that. Let me clear that. And so this is literally, or this is clearly, or hopefully clearly, equal to, this is equal to 8 times 1/3. I have 8 1/3 there. So going back to the original question, what is this equal to? 2 times 4/3 is the same thing as 8 times 1/3. And we've already seen that 8 times 1/3, well, that's literally 8 thirds. So we could also write it like this, 8 over 3. Let me do that 3 in that other color. 8 over 3 over 3. I have 8 1/3 there. So going back to the original question, what is this equal to? 2 times 4/3 is the same thing as 8 times 1/3. And we've already seen that 8 times 1/3, well, that's literally 8 thirds. So we could also write it like this, 8 over 3. Let me do that 3 in that other color. 8 over 3.
Man, I would prefer if you wrote like 6 2/3. It's improper fraction. Move the dot to the number that equals 2 times 3/4. Okay. Oh, it seems like multiplication easier than adding because we don't have like worry about the denominator. It's gonna be divided 5 6, right? Well, now the number equals 4. It's my 8 thirds. Yo, this is easier, man. For real. 14 6. 3 6. What? Wait, what? Oh, okay. So 6 times like 48 over 5. Move the dot to the number equals to, it's gonna be 5/8. Wow, this is easier. There's no GCF, LCF, LCM, whatever. How can we calculate the shaded area? It's gonna be 3, 4, 5, 6, 7, 8. 4 times 3 eighths. Choose two answers. 4 times 3 eighths. How can we calculate the shaded area? Two answers. Oh, it's gonna be 4 times 2. No, no. It can be 2 3/4 or 1, 2, 3, 4, 5, 6. Yeah. How can we calculate the shaded area? That's 6 of them. Then 6 3/4. Choose all answers to apply. Wow, this is hard. Yo, what's this? It's gonna be 18/4. This is 18/4 as well. Oh, so this is not. That's gonna be 18 1/4, right? 1, 2, 3, yeah. How can we calculate the shaded area? Choose two answers. Okay. So you have 2 4/5. 2 4/5. 8. This one's, yeah, 8 1/5. Yeah. You have 8 of those 1/5. Multiply fractional numbers on the number line. On the number line? What? Which expression matches the following number line? That's 1, 2, 3, 4, 5, 6. No, wait, 1, 2, 3, 4, 5. Yeah. Choose two answers. 100 times 5. Oh. Following number line. This is gonna be like 3. That's 3 9/10. And this guy. Which one? Okay. Those are 3 jumps, and each are 2/4. And we get 2/4, 2/4 plus 2/4. Which expression matches the following number line? It literally 6 1 6 1 2 3 4 5 6, and then we have 1 6 times 6. Whoa, what's this? Crazy. Ah, my back hurts. Oh, my back hurts. Okay, multiplication is scaling. Scaling with fractions.
We have 3 expressions here. This is 2/3 times 7/8. The second expression is 8/7 times 2/3. This third expression is 5 times 2 over 3 times 5. And what I want you to do is pause this video right now and think about which of these expressions is the largest, which one is in the middle in terms of value, and which one is the smallest. And I want you to think about it without actually doing the calculation. If you could just look at them and figure out which of these is the largest, which of these is the smallest, and which of these is in the middle. So pause the video now. Now you might have taken a shot at it.
Okay. Wait. Well, wait.
At it, and I'll give you a little bit of a hint in case you had trouble with it. All of these involve multiplying something by 2/3, and you see a 2/3 here, you see a 2/3 here, and it might not be as obvious, but you also see a 2/3 here. And let me rewrite that to make it a little bit clearer. So this first expression could be rewritten as 7 over 8 times 2/3. This second expression here could be written as what's already written as 8 over 7 times 2/3 times 2/3.
5 times
and then this
5 times
last
2/3.
expression, we could write it as, in the numerator, 5 times 2, 5 times 2, and then in the denominator, it's over 5 times 3. 5 times 3, which is of course the same thing as 5 over 5 times 2/3. times 2/3. So you see all three of these expressions involve something times
Yo,
2/3.
why is this the same?
Now I'm
Explain
looking at
to
it
me.
this way. Does it become
Isn't
easier to
that your
pick out
thing?
which of these are
Explain
the
what's under
largest,
the
which of
hood,
these are
man?
the smallest, and which of these are someplace in between? I encourage you to pause it again if you haven't thought about it yet. So let's visualize each of these expressions by first trying to visualize 2/3.
Smallest,
So let's say
middle,
the height of what
largest.
I'm drawing right now, let's say the height of this bar right over here is 2/3. So this right over here represents 2/3. The height here is 2/3. Is 2/3. So first let's think about what this one on the right here represents. This is 5 over 5 times 2/3. Well, what's
That's
5 over 5? 5 over 5 is the same thing as 1. This is literally just 1 times 2/3. This whole expression is the same thing as 1 times 2/3, or really just 2/3. So this, the height here, 2/3, this is the same thing as this thing over here. This is going to be equal to, this could also be viewed as 5 times 2 over 3 times 5, which was this first expression right over here. Now let's think about what these would look like. So this is 7/8 times 2/3. So it's less than 8/8 times 2/3. It's less than 1 times 2/3. So we're going to scale 2/3 down. This is going to be less than 2/3. It's going to be 7/8 of 2/3. So this one right over here, one right over here would look something like this. It would look something, let me see if I could draw it. Yeah, it would look something like this. If the yellow height is 2/3, then this right over here, then this height,
Just 7/8 of
this
2/3.
height right over here, we make it clear, this height right over here would be 7/8 times 2/3. Likewise, let's look at this one right over here. Let's look at this one in the middle. 8/7 times 2/3. Well, 8/7 is bigger than 7/7. It's more than 1. This is more than 2/3. This is 1 1/7 times 2/3. So it's going to be the same height as 2/3 plus another 7th. So it's going to look something, like this. It's going to look something like this. So its height, now we scaled the 2/3 up because 8/7 is greater than 1. So this right over here, this height is going to be 8 over 7 times 2/3. So the way that you could have spotted which of these is the largest and which of these is the smallest is to say, well, how are they scaling 2/3? This one right over here, you're essentially multiplying 2/3 by 1. So you're just going to get 2/3. You're not scaling it up, or you aren't scaling it down. This one right over here, you're scaling 2/3 down. You're multiplying it by something less than 1. If you multiply by something less than 1, then you're going to be scaling it down. I should say a positive number, or a number between 0 and 1, less than 1, then you're going to be scaling it down. So this thing is scaled down. It's going to be the smallest. And here you're multiplying the 2/3 times a number bigger than 1 by 1 1/7. So you're going to scale it up. So this expression is the largest, 8/7 times 2/3. The smallest is 2/3 times 7/8. And this one right over here is in between.
Because we are multiplying 16 by a fraction that is equal to 1. Yeah. All 2/3, so there we go. This one less than 1, 1 greater than 1. Greater than 17. These two guys, which are greater than 1. Okay, it's less than 930. It's less than 9. It's greater than 930.
let's think about what it means to multiply 2 over 3, or 2/3, times 4/5 times 4/5. In a previous video, we've already seen how we can actually compute this. This is going to be equal to, in the numerator, we just multiply the numerators. So it's going to be 2 times 4, 2 times 4. And in the denominator, or we just multiply the denominator, so it's going to be 3 times 5. 3 times 5. And so the numerator is going to be 8, and the denominator is going to be 15. And this is about as simple as we can make it. 8 and 15 don't have any factors common to each other than 1. So this is what it is. It's 8/15. But why does that actually make sense? And to think about it, we'll think of two ways of visualizing it. So let's draw 2/3. So let's draw 2/3. I'll draw it relatively big. So I'm going to draw 2/3, and I'm going to take 4/5 of it. So 2/3, I'm going to make it pretty big. 2/3, 2/3, just like this. So this is 1/3, and then this would be 2/3, which I could do a little bit better job making those equal, or at least closer to looking equal. So there you go. I have thirds.
Yo, the first one is the largest.
One more time. So here I have drawn thirds. 2/3 represents 2 of them. It represents 2 of them. And one way to think about this is 2/3 times 4/5 is 4/5 of this 2/3. So how do we divide this 2/3 into fifths? Well, what if we divided each of these sections into 5? So let's do that. So let's divide each into 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I could even divide this into 5 if I want. 1, 2, 3, 4, 5. And we want to take 4/5 of this section here. So how many fifths do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we got to be careful. These really aren't fifths. These are actually 15ths, because the whole is this thing over here. So I should really say how many 15ths do we have? And that's where we get this number from. But you see, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Where did that come from? I had thirds, and then I took each of those thirds and I split them into fifths. So then I had 5 times as many sections. 3 times 5 is 15. But now we want 4/5 of this right over here. So this is 10/15 right over here. Notice that's the same thing as 2/3. Now if we want to take 4/5, 10/15. But now we want 4/5 of this right over here. So this is 10/15 right over here. Notice that's the same thing as 2/3. Now if we want to take 4/5 of that, 4/5 of, if you have 10 of something, that's going to be 8 of them. So we're going to take 8 of them. So 1, 2, 3, 4, 5, 6, 7, 8. We took 8 of the 15. So that is 8/15. You could have thought about it the other way around. You could have started with fifths. So let me draw it that way. So let me draw a hole. So this is a hole. And let me cut it into 5 equal pieces, or as close as I can draw 5 equal pieces. 1, 2, 3, 4, 5. 4/5. We're gonna shade in 4 of them. It's 4 of the 5 equal pieces. 3, 4. And now we want to take 2/3 of that. Well, how can we do that? Well, let's split each of these 5 into 3 pieces. So now we have essentially 15ths again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we want to take 2/3 of this yellow area. We're not taking 2/3 of the whole section. We're taking 2/3 of the 4/5. So how many 15ths do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you have 12 of something and you want to take 2/3 of that, you're going to be taking 8 of it. So you're going to be taking 1, 2, 3, 4, 5, 6, 7, 8. or 8 of the 15ths now. So either way, you get to the same result. So one way, you're thinking of taking 4/5 of 2/3. Another way you could think of it is you're taking 2/3 of 4/5.
Okay, I wasn't kind of satisfied.
Let's think a little bit about what it means to multiply fractions. Say I want to multiply 1/2 times 1/4. Well, one way to think about this is we could view this as 1/2 of a fourth. And what do I mean there? Well, let me take a whole.
Half of a fourth.
Let me take a whole here. And let me divide it into fourths. So let me divide it into fourths. So I'll divide it into 4 equal sections. And so 1/4 would be one of these 4 equal sections. But we want to take 1/2 of that. So how do we take half of that? Well, we could divide this into 2 equal sections and then just take one of them. So divide it into 2 equal sections and then take one of them. So we're taking this pink area is 1/2, and we're going to take, or sorry, this pink area, this whole pink area is 1/4, and now we're going to take half of it. We're now going to take half of it. So that's this yellow square right over here. But what fraction of the whole does this yellow represent? Well, it now represents 1 out of 1, 2, 3, 4, 5, 6, 7, 8 equal sections. So this right over here represents 1/8 of the whole. And so we see conceptually that 1/2 times 1/4, it completely makes sense that 1/2 of 1/4 should be 1/8. And it hopefully makes sense that you get this 8 by multiplying the 2 times the 4. You started with 4 equal sections, but then you divided each of those 4 equal sections into 2 equal sections. So then you have 8 total equal sections that you split. You started with, it hopefully makes sense that you get this 8 by multiplying the 2 times the 4. You started with 4 equal sections, but then you divided each of those 4 equal sections into 2 equal sections. So then you have 8 total equal sections that you split your whole into. Let's do another example, but now let's multiply 2 fractions that don't have 1s in the numerator. So let's multiply 2/3 times 4.
That again,
fifths.
2/3
And I
and
encourage you now to
4/5.
pause the video and do something very
man,
similar
come
to what I just did.
8
Try to
15ths
represent
again.
4/5 of a whole, and then try to represent 2/3 of that 4/5 and see what fraction of the whole you actually have. So pause now. So let's think about this. Let's represent 4/5. So if I have a whole like this, let me try to divide it into 5 equal sections. 5 equal sections. So let's say that is 1 equal section, that is 2 equal sections, that is 3, 4, and 5. I can do a better job than this. This is always the hard part. I'm trying my best to make them look at least like equal sections. 2, 3, 4, and 5. I think you get the point here. I'm trying to make them equal sections. And we want 4/5. So we want 4 of these
Watch
5
the
equal
fourth
sections.
column.
So this would be 1 of the 5 equal sections, 2 of them, 3 of them, and then 4 of them. So that right over there is 4/5. Now we can view this as 2/3 of the 4/5. So how can we think about that? Well, we could take this section and divide it into thirds. So let's do that. Divide it into thirds. So we're going to divide it into 3 equal sections. So that's 1/3 and then 2/3. So we took each of the 5 equal sections and we divided them into 3 equal sections. Now what's going to be 2/3 of the 4/5? Well, that's going to be this part right over here. So let me make this clear. This is 1/3 of the 4/5, and then if we could, this would be 2/3 of the 4/5. So this right over here would be 2/3 of the 4/5, or 2/3 times 4/5. But what fraction of the whole does that represent? Well, how many total equal sections do we now have? Well, we have 1, 2, 3, 4,
and we have 8
5,
shaded.
6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 equal sections. Let me do this in a new color. we have 15 equal sections, and that makes sense. We started with 5 equal sections, but then we divided each of those into 3 equal sections. So now we have 5 times 3 total equal sections. And then how many of those are now colored in? Well, we see it's 2 times 4. 1, 2, 3, 4, 5, 6, 7, 8. Or how many of them are in the 2/3 of the 4/5, I should say? And there's 8 of them. 8 of the 15 equal sections. And so there you have it. It should hopefully now make visual sense, or it makes conceptual sense, that 2/3 times 4/5, you can obviously compute it by just multiplying the numerators. 2 times 4 is 8, and then multiplying the denominators. 3 times 5 is 15. But hopefully this now makes conceptual sense as 2/3 of 4/5. In a previous video, we saw that we could view 2/3 times 6 as whatever number is 2/3 of the way to 6 on the number line, which we saw as 4. Or another way to think about it is that 4 is 2/3 of 6. We saw 6 as whatever number is. In this video, we saw that we could view 2/3 times 6 as whatever number is 2/3 of the way to 6 on the number line, which we saw as 4. Or another way to think about it is that 4 is 2/3 of.
This wasn't even the last video. What the heck? Did we skip? Not. What the heck?
2/3 of 6.
But,
2/3
okay.
times 6 can be viewed as, well, what gets me if how many do I have if I take 2/3 of 6? Now what we want to do now is apply that same idea, but to multiplying not a fraction times a whole number, but a fraction times a fraction. So let's say that we wanted to take 3/4, and multiply it by 1/2. And we know, of course, this is the exact same thing. The order that we multiply doesn't matter. This is the exact same thing as 1/2 times 3/4. 1/2 times 3/4. So to imagine where this gets us, let's draw ourselves a number line. So this is 0, and I'll do it pretty large so that we have some space to work in. So that's 0, and then that is 1, and of course our line could keep on going. And let's first imagine 3/4 times 1/2 as 3/4 of the way to 1/2. So first let's plot 1/2 on our number line. Well, 1/2 is literally halfway between 0 and 1. So that's 1/2 right over there. And how do we think about 3/4 of the way to 1/2? Well, what we could do is think about, well, what's a fourth of 1/2? Well, we could divide this part of the number line into 4 equal sections. So that's 2 equal sections. Now that's 4 equal sections. And while we're at it, let's divide all of the halves into 4 equal sections. So let's divide all of the halves into 4 equal sections. So that's 4 sections. And now let's do this one. I'm trying my best to draw them equal sections. So I've taken each of the halves and I've made them into 4 equal sections. So this distance right over here, this gets us, or this point right over here, is 1/4 of 1/2. But that's not what we care about. We want to get to 3/4 of 1/2. So we want to get to 1, 2, 3/4 of 1/2. So this point right over here, this is literally 3/4 times 1/2. And this is, of course, 1/2 here. But what number is this? We can now visualize it on the number line. And let me do this in a new color. We can now visualize it on the number line. But what number is this actually? Well, a big clue is that, well, before we had the section between 0 and 1 divided into 2 equal sections when we only had to plot 1/2. But then we took each of those 2 equal sections and then split them into 4 more sections. So each of these, by doing that, we now essentially have divided the section between 0 and 1 into 8 equal sections. So each of these is actually 1/8. So this point right over here is 1/8. This is 2/8. And then this is 3/8. And that's in line with what we've seen about multiplying fractions before. This should be equal to 3 times 1 over 4 times 2. 4 times 2, which is equal to 3/8. Which is equal to 3/8. And everything that we're talking about, this all, so we don't get confused, this is all referring to this point right over here on the number line. This point right over here. But what if we thought about it the other way around? What if we thought about it as 1/2 of the way to 3/4? So we could divide the space between 0 and 1 into fourths. So let's do that. So that is 1/4, 2/4, 3/4. So this right over here is the number 3/4. And we want to go half of the way to 3/4. Well, what is half of the way to 3/4? Well, we split this section into two equal sections. So we could split right over there. We could split right over here. And we want to go exactly one of those sections. 1/2 of 3/4 gets us, once again, right over here to this point 3/8. So either way you imagine it, whether you're essentially taking 3/4 of 1/2 or saying, I'm going to go 3/4 of the way to 1/2, or you say, I'm going to go 1/2 of the way to 3/4, either way, hopefully it now makes conceptual sense. You can visualize it, and it makes numeric sense that this is going to be equal to 3/8. Full sense. We go words of
what?
We could second through is 1/4, 1 and 3, the other into 2 3/4, and we want to go half of the way to 3/4. Well, what is half of the way to 3/4? Well, we split this section into two equal sections. So we could split right over there. We could split right over here. And we want to go exactly one of those sections. 1/2 of 3/4 gets us, once again, right over here to this point 3/8. So either way you imagine it, whether you're essentially taking 3/4 of 1/2 or saying, I'm going to go 3/4 of the way to 1/2, or you say, I'm going to go 1/2 of the way to 3/4, either way, hopefully it now makes conceptual sense. You can visualize it, and it makes numeric sense that this is going to be equal to 3/8.
Yep.
We're asked to multiply 5 6 times 2/3 and then simplify our answer. So let's just multiply these two numbers. So we have 5 over 6 times 2/3. Now when you're multiplying fractions, it's actually a pretty straightforward process. You just multiply the new numerator, the numerator of the product, is just the product of the two numerators, or your new top number is the product of the other two top numbers. So our the numerator in our product is just 5 times 2. So it's equal to 5 times 2 over 6 times 3 over 6 times 3, which is equal to 5 times 2 is 10, and 6 times 3 is 18. So it's equal to 10/18. And you could view this as either 2/3 of 5/6 or 5/6 of 2/3, depending on how you want to think about it. And this is a right answer. It is 10/18. But when you look at these two numbers, you immediately, or you might immediately see that they share some common factors. They're both divisible by 2. So if we wanted in lowest terms, we want to divide them both by 2. So divide 10 by 2, divide 18 by 2, and you get 10 divided by 2 is 5. 18 divided by 2 is 9. Now, you could have essentially done this step earlier on. You could have done it actually before we did the multiplication. You could have done it over here. You could have said, well, I have a 2 in the numerator, and I have something divisible by 2 in the denominator. So let me divide the numerator by 2, and this becomes a 1. Let me divide the denominator by 2, and this becomes a 3. And then you have 5 times 1 is 5, and 3 times 3 is 9. So it's really the same thing we did right here. We just did it before we actually took the product. You could actually do it right here. So if you did it right over here, you'd say, well, look, these are eventually going to, 6 times 3 is eventually going to be the denominator. 5 times 2 is eventually going to be the numerator. So let's divide the numerator by 2. So this will become a 1. Let's divide the denominator by 2. This is divisible by 2, so that'll become a 3. And it'll become 5 times 1 is 5, and 3 times 3 is 9. So either way you do it, it'll work. If you do it this way, it kind of, you get to see the things factored out a little bit more, so it's usually easier to recognize what's divisible by what. Or you could do it at the end and put things in lowest terms.
Multiplying fractions. To multiply fractions, we multiply the numerator and then multiply the denominators. 5 6 times 5 over 7. It's 5 times 5 over 6 times 7. It's 25 over 42, mixed numbers. Before multiplying, we need to write the mixed numbers as improper fractions. Multiply them whole number and then add the numerator. Yep. Here is how we write 1 and 3/5 as 8/5. 8/5, yeah. Cool. It's gonna be 64/15. Wow, that's insane. Oh, okay. You can also write this as 4/4/15. Yep. Cross to this way to simplify from this. Oh wow, it's amazing. 3 times 9, both divisible by 3. So we have 1 and 3. I mean 2. Okay, it's 1, 2. Three. Okay. This is gonna be 35, 40, 48, right? Oh shit! Wait, what? Oh, 64. Um, 430. Can I simplify this? Yeah, we can simplify it, man. Divide it by 4. Wait, we can divide it by 2 actually. Okay. Wow, what's this? 3 times 2 and 2/5. So we're gonna turn it into proper fraction first, right? So we have 12/5 and then 36/5. There's what is the area of the stripe? Rectangle. Okay, it's 21 and then 8 of the 21. Right? What is 2/3 of 3/8? Okay, it's gonna be 6. Wait, what? Oh yeah, okay. I'm gonna 604, right? So I'm gonna simplify this. Like this was 6 and 1/4. What is 2/3 of 9/10? 18, 30, 15, 9. What is their striped region? Oh shit, this is hard. Okay, so this is 1, 2, 3, 12, 24. Oh shit, so it's gonna be over 24. Over 12. 6, 12. Then like what's this? 6, 9. 12. So I guess it's like 3/4, right? Yo, this is insane. Multiplying fractions. 49 and 36. Multiply 16 and 81. That's going to be 230. Yeah, it's 230. 230. This 115. 27. Okay, it's gonna be 1856. Yo, 1856 and 928. 449. Let me simplify this. Probably not. 7 times 49, right? Yeah. With visuals. Which expression represents the image below? Wow, this is hard. So this is 3 2 over number crap. Yeah, it's 3 2, right? So we're gonna have some 3 2 in. This is 5. But this isn't 6. This is fourths. 4. Oh crap. It could be this one as well. Yo, this is insane. This B is not wrong. It could be 5, 6, or this is 3 2s. And this is 5 6. No, this is actually 6 fourths. We don't have 6 fourths here. What the hell? Okay, so we're actually taking like 5 6 of the 3 fourths out of 2 thirds. 2 thirds and then 5 6 of that. The 6. Oh yeah, get it now. Cool. The area of a rectangular figure below is 1 square unit. How can we describe the area of the striped rectangle? It's 3 by 1 2 3 4 5. 3 by 10. And then it's gonna be like 4. This is 2 thirds. Then like 4 tenths. Which expression represents the shaded length of the number line below? Okay. We have 5 fourths. 2 thirds of 5 fourths. Okay, so we have 1 2 3 4 8. Oh no, this is 7. 6 7. 1/2 of 6 7. Oh, let's do the quiz. 7 questions. Which expressions match the following number line? It's gonna be 1. No. Choose 2 answers. 3 times 1/2. Multiply. So we have 35 and 48. Choose 1 answer. It's correct. Like, that is greater than. Because 5 fourths is greater than 1. Because we are multiplying side by prime, that is greater than 1. The area of each square below is 1 square unit. Well, how can we describe the area of a striped region? Okay. So this is 2 thirds. 5 fourths. So we have 2 thirds, and then in terms of this guy, 1 2 3 4 5. 5 no, not 5 fourths. Although this is really 2 thirds. Oh shit, this is hard. Oh, so this is This is like 1, 2, 3, 4, 5. Yo, this is a lot. Yo, what the hell? Yep, 2/3. 4/12 of 2/12. We don't have 2/12. Yo, I know the A is the answer, but I don't understand why. I can clearly roll this out and this guy. 5/4. This is 2 5/4. Or it could be real like 2 5/4. So this one is like 1, 2, 3, 4, 5, 6, 7, 8, 8, 16. No. Oh my god, this is hard. Whoa. This is 2/3. And then we have 5/4. Yeah. Okay, so this pink or something like pink is 5/4. Yo. This is 4 divided and then 5. Okay, it's A. What is 1/2 of 2/3? Okay, so this is 2/3 and then a half of that's gonna be 1/3. Yo, it's 1/3, right? So we're like gonna have 2 6 and then it's gonna be like 1/3 anyway. How can we calculate the shaded area? We have 2/3 times 5. 1, 2, 3, 4, 5, 2/3. Choose 2 answers. Holy shit. Or we can have 10 of those. 1, 2, 3, 4, 5, 6, 10. 10 times 2/3? No. Okay, finished with quiz 6. I'm running for an hour and 12 minutes. Holy shit, it's a ton more. But I can go for more. Multiply mixed numbers, so I'm pretty sure this is gonna
Multiply
be
1 and
converting it
3/4
improper
times
first.
7 and 1/5. Simplify your answer and write it as a mixed fraction. So the first thing we want to do is rewrite each of these mixed numbers as improper fractions.
7.
It's very difficult, or at least it's not easy for me to directly multiply mixed numbers. One can do it, but it's much easier if you just make them improper fractions. So let's convert each of them. So 1 and 3/4. 1 and 3/4 is equal to, it's still going to be over 4. So you're still going to have the same denominator. But your numerator as an improper fraction is going to be 4 times 1 plus 3. 4 times 1 plus 3. And the reason why this makes sense is 1 is 4/4, or 1 is 4 times 1/4. Right? 1 is the same thing as 4/4. And then you have 3 more fourths. So 4/4 plus 3/4 will give you 7/4. Will give you 7/4. So that's the same thing as 1 and 3/4. Now let's do 7 and 1/5. 7 and 1/5. 7 and 1/5.
Over
Same
5.
exact process. You're still going to have, we're going to still be talking
12.
in terms of fifths. That's going to be the
12
denominator.
over 3/5.
And you take 5 times 7, because think about it. 7 is the same thing as 35/5. So you take 5 times 7, so it's 5 times 7
Plus what?
plus this numerator right here. So 7 is 35/5. Then you have one more fifth. So you're going to have 35 plus 1, which is equal to 36/5. So this product is the exact same thing as taking the product of 7 over 4 times 36 over 5. Times 36 over 5. And we could multiply it out right now, take the 7 times 36 is our new numerator. 4 times 5 is our new denominator. But that'll give us large numbers. I can't multiply 7 and 36 in my head, or I can't do it too easily. So let's see if we can simplify this first. So both our numerator and our denominators have numbers that are divisible by 4. So let's divide both the numerator and the denominator by 4. So the numerator, we can divide the 36 by 4.
And
we
we
can
get
divide the
9.
36 by 4 and get 9. And if you divide something in the numerator by 4, you have to divide something in the denominator by 4. And the 4 is the obvious guy. So 4 divided by 4 is 1. So now this becomes 7 times 9. And what's 7 times 9? It's 63 over
5.
1 times 5 over 5. So now we have our answer as an improper fraction, but they want it as a mixed number or as a mixed fraction. So what are 63 fifths?
12
So to figure that out,
3/5.
12
and 3 over 5.
Here. We take 5 into 63. 5 goes into 6 one time. 1 times 5 is 5. You subtract. 6 minus 5 is 1. Bring down the 3. 5 goes into 13 2 times. And you could have immediately said 5 goes into 63 12 times, but this way it's at least to me it's a little bit more obvious. And then 2 times 5 is 12 is 12.
And then we have sorry.
And then we have
Sorry.
2 times 5 is 10. 2 times 5 is 10. It tells you not to switch gears in the middle of a math problem. 2 times 5 is 10. And then you subtract, and you have a remainder of 3. You have a remainder of 3. So 63 fifths is the same thing as 12 wholes and 3 left over, or 3 fifths, or 3 fifths left over. And if you wanted to go back from this to that, just think 12 is the same thing as 60 fifths, or 60 over 5. 60 over 5 plus 3 over 5 is 63 over 5. So these two things are the same thing. These two things are equivalent. This is as an improper fraction. This is as a mixed number, or a mixed fraction. But this is our answer right there, 12 and 3 fifths.
Okay, so I'm gonna write here. So this is gonna be 77 over 10. So you're right here. Why am I writing 77? What the hell? Why am I multiplying by 10? 10 17 over 10 times 5 over 1. So what's 17 times 5? 35. 3, 5. 85 over 10. And then that's gonna be like 8 over 5 tenths, or 1/2. Oh, cool. 2 answers. So this guy is one of the answers, and we have like, what is this? 5 tenths. Yo, what's the other answer? 85 over 10. Why is it 75? This is not. This is wrong. It's clearly wrong. I think this is the other answer. You can like, yeah. Since it's divisible by 5, yeah, it's gonna be like 2 and 1. So yeah, that's correct. Cool. So it's gonna be 2, 4, 9 halves, and by 4, it's gonna be like 36, and it's gonna be 8, just 18, right? Oh shit! Oh, holy crap! So 2 times 2 is 4. This one is 5. Bullshit, why did it say 9? Maybe it's... oh crap, maybe it's because I'm really yawny right now or something. 20 or... what is 3? But I don't... I must give up. I must finish the whole section. What is 3, 5, 6 times 2? It's gonna be 18, 23 over 6 times 2 over 1. It's gonna be 23 over 3. Choose 2 answers. So this is the other answer. And then what is the other answer? Oh, okay. So the other answer is like 7 over 1/3. Oh, not 1 to 2/3 actually. Multiply 17, 12 times 2 over 1. Now 17 over 6. And that's gonna be 2 and 5, 6, right? What is 4 and 1/2 times 2? 2 answers. Okay, 2 times 4 is 8 plus 1 is 9 over 2 times 2. Then we got cancel those guys. So we actually just have 9. And then yo, what the hell? So this one's the answer. So 8 and plus 3 is 11 over 4 times 2, and this one 11 over 2. What is 3 times 2 and 1/4? 2 times 4 is 8 plus 1 is 9 over 4. 9 over 4 times 3. With 27 over 4. Or we can have like 8 and wait, no. 27 and 4, like 4 goes into that like 6 times only. So we have 4, 6, 24, 6 and 3/4. Why did I say 8? That's 32. 6, 7 thirds and 3. 7. Sub 7. Multiply mixed numbers. Okay, that's 4. That's 4 7/4 over 5. We have 35 over 4. 6, 7, 8/3 times whoa, it's the same shit. 6, 8. Yo, okay. 64, 9. 3, 11 times 12, 13 over 4. There's nothing really can simplify here. Can we? No. So I have 39 over 44. Gonna be 12 over 5 times 3. Nothing. So we have 36 over 5. It's one of the answers. Oh, just one answer. Okay. So we get 7 1/5. Muffins.
A recipe for banana oat muffins calls for 3/4 of a cup of old-fashioned oats. You are making 1/2 of the recipe. How much oats should you use? So if the whole recipe requires 3/4 of a cup, and you're making half of the recipe, you want half of 3/4, right? You want half of the number of old-fashioned oats as the whole recipe. So you want 1/2. You want 1/2 of 3/4.
Sec, I'll be back. Alright, I'm back, boys.
1/2 of 3/4. So you just multiply 1/2 times 3/4. And this is equal to, you multiply the numerators. 1 times 3 is 3. 2 times 4 is 8. And we're done. You need 3/8. You need 3/8 of a cup of old-fashioned oats. And let's visualize that a little bit, just so it makes a little bit more sense. Let me draw what 3/4 looks like, or essentially how much oats you would need in a normal situation, or if you're doing the whole recipe. So let me draw. Let's say this represents a whole cup, and if we put it into fourths, so let me divide it a little bit better. So if we put it into fourths, you put it into fourths. 3/4 would represent 3 of these. So it would represent 1, 2, 3. It would represent that many oats. Now, you want half of this, right? Because you're going to make half of the recipe. So we could just split this in half. We could just split this in half. Let me do this with a new color. So this you would normally use this orange amount of oats, but we're going to do half the recipe. So you'd want half as many oats. So you'd want half as many oats. So you would want this many oats. This many oats. Now let's think about what that is relative to a whole cup. Well, one way we can do it is to turn each of these 4 buckets, or these 4 pieces, or these 4 sections of a cup into 8 sections of a cup. Let's see what happens when we do that. So we're essentially turning each piece, each fourth, into 2 pieces. So let's divide each of them into 2. So this is the first piece. We're going to divide it into 2 right there. So now it is 2 pieces. And then this is the second piece right here. We divide it into 1 piece and then 2 pieces. This is the third piece. So we divide it into 1, 2 pieces. And this is the fourth piece, or the fourth section. And we divide it into 2 sections. Now, what is this? What is this as a fraction of the whole? Well, we have 8 pieces now, right? 1, 2, 3, 4, 5, 6, 7, 8. Because we turned each of the 4, we split them again into 8. So we have 8 as a denominator. And we took half of the 3/4, right? Remember, 3/4 was in orange. Let me make this very clear, because this drawing can get confusing. This was 3/4 right there. So that is 3/4. This area in this purple color, is 1/2 of the 3/4. But let's think about it in terms of the 8s. How many of these sections of 8 is it? Well, you have 1 section of 8 here, 2 sections of 8s there, 3 sections of 8. So it is 3/8. So hopefully that makes some sense, or gives you a more tangible feel for what it means when you take 1/2 of 3/4.
It makes sense.
Gina had 2/3 cups of laundry detergent. She used half of the detergent on Friday to wash all of her sheets. How much detergent does she have left? So we're essentially going to take half of 2/3, or 1/2 times 2/3. So let's see which of these choices match up. So we should be taking 1/2 times 2/3. Well, here they're taking 2/3 minus 1/2, so this isn't going to be right. Here they're going to be taking let's see, 1/3 because 2/3 times 1/2. This is exactly what we want to do. We want to take half of 2/3. And we multiply the numerators. 2 times 1 is 2. Multiply the denominators. 3 times 2 is 6. You have 2/6. You could say that 2/6 has either been used up or 2/6 is left. And 2/6 is the exact same thing as 1/3. Divide the numerator and the denominator by 2. So this looks right. And so here, 1/6 cup. Well, we know it's not 1/6 cup. We know it's 1/3 cup. So here, 1/3 cup, because 2/3 is equal to 1/3 plus 1/3. That's right. So half of 2/3 must be 1/3. This is exactly right as well.
Wait,
These
what? 2/3 is equal to 1/2 plus 1/2. So half of 2/3.
Both completely reasonable ways to getting the right answer. That Gina has 1/3. She used 1/3 of a cup of laundry detergent, and she has 1/3 left. You can ride your bike 1/5 of a mile per minute. If it takes you 3 1/3 minutes to get to your friend's house, how many miles away does your friend live? And here's pictures of these guys on bicycles. It's pretty clear they're not riding to work, or some of these guys aren't even riding a bicycle. But let's focus on the question. So you can ride your bike 1/5 of a mile per minute, and you're going to do this for 3 1/3 minutes. Times 3 1/3. So we really have to figure out how do we multiply 1/5 times 3 1/3. So there's a couple of ways to think about it. You could literally view a 3 1/3 as this is the same thing as 1/5 times 3 plus 1/3. That's exactly what 3 1/3 is. And then we can just apply the distributive property. This would be 1/5 times 3. 1/5 times 3. I'm going to keep the colors the same. Times 3 plus 1/5 times 1/3 times 1/3. And this is going to be equal to, well, we could rewrite 1/5 times 3 as 1/5 times 3 over 1. That's what 3 really is if we wrote it as a fraction. And then, of course, we're going to have plus 1/5 times 1/3 times 1/3. And let's just think about what each of these evaluate to. Here, you multiply the numerators and you multiply the denominators. So this is going to be equal to 1 times 3 over 5 times 1. And this business right over here is going to be, and remember, order of operations, we want to do our multiplication first. So this is going to be 1 times 1 over 5 times 3, over 5 times 3. And so that's going to be equal to 3 over 5 plus 1 over 15. And now we have different denominators here, but lucky for us, 3 over 5, if we multiply the numerator and the denominator by 3, we're going to get a denominator of 15. And so that's equal to 9 over 15 plus 1 over 15, which equals 10 over 15. And if you divide the numerator and the denominator both by 5, you're going to get 2 over 3. So your friend lives 2/3 miles away from your house. Well, that's kind of interesting, and this was kind of a long way to do it. Let's think about if there's a simpler way to do it. So this is the same thing as 1/5 times, and I'm just going to write 3 1/3 as a mixed number. So it's 1/5 times 3 1/3 can be rewritten as 9/3. Sorry, I'm going to rewrite 3 1/3 as an improper fraction. So this is the same thing as 9/3. That's 3 plus 1/3. Which is the same thing as 1/5. Wow, I switched colors arbitrarily.
So really weird.
Which is the same
The first thing he did, the 3 and 1/3, he took the 3 and multiplied to the 1/5.
As 1/5 times 9/3 plus 1/3 is 10/3. And now we can just multiply the numerator and multiply the denominator. The numerator, or multiply the numerators. So this is 1 times 10. 1 times 10. I'm trying to stay good with the color coding, over 5 times 3, over 5 times 3, which is exactly equal to what we just got. 1 times 10 is equal to 10. 5 times 3 is 15. 10/15 we already established is the same thing as 2/3. So your friend lives 2/3 of a mile away from you. 2/3. So you're
Oh, this is plus. So we ended up with this. So we can 2 times 3. This is 5, right? So divided by 5, we have 1.
friend lives 2/3 of a mile away from you.
Okay. Erica started running for exercise. He's recorded the number of miles he ran each day. This week in the table below. On Monday, Eric ran 5/7 the distance that he ran on Friday. Fill in the number of kilometers that Eric ran on Monday in the table below. So 5/7 on what he did on Friday. 910 times 5/7. It's gonna be like 1 and 2. We have 9 over 14. At the candy store, Sophie filled a bag with 2/3 kilogram of candy. 1/4 of the weight of candy was from chocolate covered pretzels. How much did they go? Okay, so it's gonna be 2, 6, 8/3 times 1/4. So you have 8/12 or 3/4. Yo, what? Be 1, 3, and then 4, 2. 2/3. Yo, what the heck? Carl spent 4, 5 doing. He spent as much. He spent 1 and 1 for as much time practicing piano. He spent as much as. Okay. Multiply, so 5/4 times 5/4. Yo, what is this? She recorded the amount of times she practiced her lines each day this week. On Tuesday, she practiced 2/3 of the times that she practiced on Wednesday. Alright, so Wednesday 5/6 and 2/3 of 5/6 times 2/3. 2/3. You know, 5 and then 3. 9. 5, 9. She was lost. Okay, so we have 3, 2 times 5/6. So we have 5, 1 and 2. Yo, what the heck? She's lost for quite a while. 1 and 1/4. Is for real? Is that even allowed? Like, no, let's try it again. 2, 3 halves times 5, 6. 1, 2 plus 5, 4. It's 1 and 1/4, man. Yo, that's insane. Junior's proudest 1, 2, 3, 2. Junior is 1 and 1/5 of his brother's height. How tall is Junior? Okay. 5, 6. 1, 3, 9, or 1 and 4/5. Talia spent 3/4 of this week's allowance on one candy. Okay, so I have 3/4 times 5/6. I have 1, 2, 5/8. No, quiz 7. Okay, what is 2 and 2? So we have 2, 6, 8/3 times 3. We have this 8. 2 answers. Yo, it could be 3 times 24. So Jackie loves to cook fried food. She recorded the total amount of oil that she used each month. February 2/3 times 3/5. This 1, 2. I'll multiply. So 4/3 times 4/7/3. So we have like 28/9, which is also the same as 3 and 1. Yo, what the heck? Yo, I can't say math. No. 3/4 times 4 plus 3 7/3. 4 times 7 is 28. 3 times is 9. 9 goes into 28 3 times. So we have, whoa. Four times 7 is 28. Yo, what the hell? Let's try this again. 3/4 times like 4 plus 3 is 7/4. Oh shit, I wrote 3 instead of 4. Okay. It'll be 7/3 or 2 and 1/3. Multiply. 12 5 times 4 48/5 or 9 and 3/5. Natasha spent 1.5 hours on the beach. Fell asleep for terrible sunburn. Oh gosh. Oh no. Okay, so 2, 3 times 3/4. We have 9, 8 or 1 and 1, 8. Fractions is division.
When we were first exposed to multiplication and division, we saw that they had an inverse relationship, or another way of thinking about it is that they can undo each other. So for example, if I had 2 times 4, one interpretation of this is I could have 4 groups of 2. So that is 1 group of 2, 2 groups of 2, 3 groups of 2, and 4 groups of 2. And we learned many videos ago that this, of course, is going to be equal to 8. But we could express a very similar idea with division. We could start with 8 things. So let's start with 1, 2, 3, 4, 5, 6, 7, 8 things. So now we're going to start with the 8. And we could say, well, let's try to divide that into 4 groups, 4 equal groups. Well, that's 1 equal group, 2 equal groups, 3 equal groups, and 4 equal groups. And we see when we start with 8, divide into 4 equal groups, each group is going to have 2 objects in it. So you probably see the relationship. 2 times 4 is 8. 8 divided by 4 is 2. And actually, if we did 8 divided by 2, we would get 4. And this is generally true. If I have something times something else is equal to whatever their product is, if you take the product and divide by one of those 2 numbers, you'll get the other one. And that idea applies to fractions. And it actually makes a lot of sense with fractions. So for example, let's say that we started off with 1/3, and we wanted to multiply that times 3. Multiply by 3. Well, there's a couple of ways we could visualize it. Actually, let me just draw a diagram here. So let's say that this block represents a whole. And let me shade in 1/3 of it. So that's 1/3. We're going to multiply by 3. So we're going to have 3 of these 1/3. Or another way of thinking about it is going to be 1/3 times, or 1/3 plus another 1/3 plus another 1/3. That's our first third, our second third, and our third third. And we get the whole. This is 3/3 or 1. So this is going to be equal to 1. So you use the exact same idea. If 1/3 times 3 is equal to 1, then that means that 1 divided by 3, must be equal to 1/3. And this comes straight out of how we first even thought about fractions. The first way that we ever thought about fractions was, well, let's start with a whole.
Yeah.
And that whole would be our 1. And let's divide it into 3 equal sections, the same way that we divided this 8 into 4 equal groups. So if you divide this into 3 equal sections, the size of each of those sections is going to be exactly 1/3. Now this leads to an interesting question that might be popping in your brain. Notice we have 1 as the numerator, 3 as the denominator, and we just said that this is equal to the numerator divided by the denominator. 1/3 is the same thing as 1 divided by 3. Is this always true for a fraction? Well, let's just do the same thought experiment, but let's do it with a different fraction. Let's take 3/4 and multiply it by 4. So multiply it by 4. So once again, let's see if I could draw a 4th here. Let me do this in a new color. So I'll take, let's say that this block right over here is a whole. I'm going to divide it into 4 equal sections. So now I've divided it into fourths, and let me copy and paste it so I can use it multiple times. So copy. All right. Now 3/4. That's going to be 1. We can assume I didn't draw it perfect. Actually, I could draw it a little bit better than that, just to make the 4 equal sections actually look equal. So that looks like a little bit better of a job. I'm trying to make them 4 equal sections. And let me copy that one. So let me use it for later. Now 3/4. This is 4 equal sections, and 3/4 represents 3 of them. 1, 2, 3. But now we're going to multiply it by 4. So we're going to have 3/4 4 times. So we're going to need some more holes here. So let's throw in another hole. So this is 1/3.
Copy the
now
one.
Let me do the next
shaded.
3/4 in another color. So this is another. That's a 4th. That's a second 4th. That's a third 4th. That's another 3/4. And now let's do. So we've done 2 3/4 just now. Let me make it clear. This is the first 3/4, and then this plus this is the second 3/4. Now let's do a third 3/4, and we're going to have to use another hole right over here, and I will do that in this color. So my third 3/4. So here's a 4th. Here's my second 4th. Here's a third 4th. So in green I have another 3/4, and now we need 4 3/4. So let's do that in a color I have not used yet, maybe white. So that's a 4th. That's 2/4, and that is 3/4. So notice now I have 1 3/4 2 3/4, 3 3/4, and 4 3/4. And what did I do when I got those 4 3/4? Well, it's pretty clear. This is turned into 3 wholes. So this is equal to 3 wholes. Well, if 3/4 times 4 is equal to 3, that means that 3 divided by 4, 3 divided by 4 is equal to 3/4. Is equal to 3/4. So the same idea again. 3 over 4 is the same thing as 3 divided by 4. And in general, this is true. The fraction symbol here can be interpreted as division. And looking at this diagram right here, it made complete sense. If you started with 3 wholes and you want to divide it into 4 equal groups, 1 group, 2 groups, 3 groups, 4 groups, each group is going to have 3/4 in it. My wife and I have recently purchased an assortment pack of soap, and we both want to experience all 3 bars, and we are not willing to share soap with each other. So we have a little bit of a conundrum. How do we share these 3 bars of soap so that we each get to experience all of the smells? So this might be a nice rose smell. This might be some type of, I don't know, ivory smell. I don't even know if that's a legitimate smell. This might be some type of sandalwood, which is always very nice. And my wife has an idea. She says, look, I'm going to take these 3 bars. So we're starting with 3 bars of soap. And I'm going to divide it into 2 equal groups. And I said, how are you going to do that? And she says, well, I'm just going to take out some type of carving saw or carving knife or who knows what it is. And I'm just going to cut it right down the middle. So right down this. This is my wife cutting the soap right over here with her saw. So she's cutting the soap right over here. So she has divided the soap into 2 equal groups. So she's taken 3 bars and she's divided into 2 equal groups. So the interesting question here is, how many bars of soap do we each have now? And I encourage you to pause the video and think about that for a second. How many bars of soap do we each have now?
Each of one of you guys.
Well, let's just visualize my share. Let's say I take this bottom half right over here. So this is Sal's share of the soap. Let me write this out. So this is Sal's share. My wife took this top half. Well, what do I have? Well, I have 1/2. I have another 1/2, and I have another 1/2 of a bar. So I have 3 1/2s of bars of soap. Or you could say that I have 3 times 1/2, 3 times 1/2 bars of soap. Notice something very interesting happened here. 3 divided by 2 is equal to 3 times 1/2. And we could make it even more interesting because we know 2 is the exact same thing as 2 over 1. So 3 divided by 2 over 1 is equal to 3 times 1/2. Notice we went from a division to a multiplication, and we took the reciprocal. And that makes complete sense.
Reciprocal.
We have 3
Come on, man.
bars now. But what's 3 times 1/2? Well, 3 times 1/2 is equal to 3 halves. So just doing this little simple smelly soap example, we got a very interesting result. 3 divided by 2 is the same thing as 3 times 1/2, which is the same thing as 3 halves.
Interesting. Which expression is equals 9 divided by 8? Which of the following represents the length of the rectangle shaded in blue? Yo, what is this? Yo, what is this? Yo, what is this? And what shit is this? the length of the rectangle shaded in blue. Yo, I guess it's 3/5. Yo, it's 3/5, right? Yo, but yo, I'm not sure why it's 3/5. I mean, in relation to this guy, it looks 3/5, right? So this is in fifths, and then it's 3. So it's kind of getting yo, I'm gonna take a screenshot of this. S- 7/12. Oh, this is 7 divided by 2. It's 5 divided by 9. What fraction must be equal to which expression? This is hearts divided by diamond. Hearts divided by diamond. Just one answer. Divide 8 times 5. It's 8/5. Which expression is equal to 4/64 divided by 6? Divided by 6. Relate fraction division to fraction multiplication. Okay. Hannah wants to use multiplication to solve 2 divided by 1 equals C. Which multiplication can Hannah use? Holy shites. If we're gonna multiply and then reverse, like, we're gonna go times 4. Yo, what? Should be 2 times 4, right? I mean, this one's already like, yo, what the hell? This is the same shit. I mean, yeah, 8 times 1/2. Yeah, it's gonna be like 2 and then 1. It's gonna have 2. That is insane. 2 equals 4 times 1/2. 4 times 2. Which is same as 1/2. 1/2 is equal. No. 4. No, yeah. 2 divided by 4 is 1/2. Yo, this is hard. Same thing as like 20 divided by 4 is certainly not 1/5. Yo, this relation is hard. Okay. It's just this one, right? Apparently not. This one? Yo, I don't want to guess. I don't want to guess. I need to know why. It's surely it's gonna be this is gonna be 80. Yo, 4 divided by 20 is 1/5. Oh yeah, it makes sense. 20. No. It's gonna be 8 times 1/3, right? 8 times 1/5 equals 3. Yo. Oh shit, 3 times 8. Let's try again. K times 7 is 1/3. Oh, what the heck? This is the answer? What the fuck? 1/5 times W. Yo, this is the same. 5 times 1/5 and 1/5 times 5. And this one's 5 equals 1/5 times W. 5 divided by... Shit, this is hard to understand. Can have... we want 72 divided by 9. Or 9 divided by 1/8. 9 1 divided by 9. Or 9 divided by 1/8. Holy shit. This is different shit. This is hard. Isn't this the same shit? Like 1/8 divided by 9. So if we have 3 divided by, or let's say 10 divided by 5, it's 2, and 5 divided by 10 is not. Yo, this shit's hard. If we actually try to solve this, we have 9/8. It's either of these two. But this is 9 over 1 times 8 over 1. And this one's like 1 over 8 times... Yo, this is hard. 9 okay. Nell wants to use multivariable to solve m. What multiplication equation can Nell use? You know what? I can just like do the still m now. M. If we switch this guy over to the left, so it's gonna be multiplication. Right, left bit. This actually should be C. Let's put it out. I want to try it again. Can I do it again? I want to do it again. Forty-two times 1/6. 42 times 1/6. equals 7. So we have k times 1/3. Now let's use solve m. Got 1/2, so we transferred a to the other side. We get 1/2 times a. Okay.
So let's see if we can figure out what 1/3 divided by 5 is. And I'll give you a hint. Try to draw out 1/3 of a whole and then divide it into 5 equal sections. Pause this video and try to do that. All right, now let's try to work through it together. And to help us, as I promised, or as I suggested, I guess, we said, let's draw a third. So I will represent a whole by that square right over there. And now let me split it up into 3 equal sections. So this is all hand drawn with the aid of a computer, so it's not going to be perfect. But let's say that that is 3 equal sections. It's roughly 3 equal sections. I didn't do it perfectly, but you hopefully get the idea. And so 1/3 would be one of those 3 equal sections. So that's a third right over there that I have just shaded in. And I want to divide it into 5, or I want to divide it by 5, I should say. So let's do that. So to divide it by 5, I'm going to divide it into 5 equal sections. And if I'm dividing that one into 5 equal sections, let me just divide all of the thirds into 5 equal sections. I'm essentially just going to make 5 rows here. 1, and I'm going to eyeball it, so it's going to be approximate. 2, 3, and then 4 and 5 equal sections. So notice I now split this whole into 1, 2, 3, 4, 5 rows of equal height. Now, if I go to my original third and I divide it by 5, I would be left with this right over here. But what fraction is this of the whole? Well, what I've done now is I've split my whole into 15 equal sections. How do I know that? Well, I could count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Or you could just say, look, I had 1, 2, 3 thirds, and now each of those have been split into 1, 2, 3, 4, 5 equal sections. So 3 times 5 is 15. So each of these is a 15th, and so the 1/3 divided by 5 is just one of those 15ths. So that right over there is one of those 15ths. So this is going to be equal to 1/15. And we are done. Let's think about what 3 divided by 1/4 is equal to. Pause this video and see if you can figure it out on your own. And I'll give you a hint. Take 3 wholes and divide it into pieces or sections that are each 1/4 of a whole. And then think about how many sections you have.
Yeah, it's 1/4.
All right, now let's work through this together. Now let me draw 3 holes. And so let's say this is, I'm going to hand draw it, so it's not going to be perfect. But let's say that is 1 hole right over there. This is 2 holes right over there. And then I have my 3rd hole, just like that. And now I'm going to divide it into pieces that are, or sections that are each 1/4 of a whole. So this first hole is 4 pieces that are each 1/4 each, or 4/4. And then I have another 4/4 right over here. And then I have another 4/4 right over here. Another way to think about it, I took the 3 holes and I divided it into fourths. So if you divide it into fourths, how many pieces am I going to have? Well, this is pretty straightforward. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. And I didn't even have to count that. Each hole is going to be 4/4. So 3 holes is going to be 3 times 4/4, or 12 pieces, or 12 sections. So that is going to be equal to 12. Another way to think about it is, if you take 3 and you divide it into equal sections that are each 1/4, you're going to have 12 equal sections.
Makes sense. Whoa. What? Oh, it's the other way around. Should be 1/6, right? Why is this wrong? Yo, what the heck? Well, this one's pretty hard. Yo, it should be 1/6, right? If you divide 3 into 1/2. Yo, I'm doing the reciprocal trig thing. Haven't I watched this video?
And divide it into pieces or sections that are each 1/4 of a whole, and then think about how many sections you have.
Yeah, we already watched this one.
Then divide it into fourths, 9, 12, another one that are each a fourth. You're going to have
One half same as 1/2 divided by 3. 4. Kaya lang nga ba record? 4 and 21 minutes. Dividing fractions by fractions. Oh shit,
Let's
we're gonna
think
do the
about what it
reciprocal
means to
thing.
take 8/3 and divide it by 1/3. So let me draw a number line here. So there is my number line. This is 0, this is 1, and this is 2, and maybe this is 3 right over here. And let me plot 8/3. So to do that, I just need to break up my each whole into thirds. So let's say it's 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3, 8/3. So right over here, and then of course 9/3 would get us to 3. So this right over here is 8/3. 8/3. Now one way to think about 8/3 divided by 3 is, what if we take this length and we say how many jumps would it take to get there if we're doing it in jumps of 1/3? Or essentially we're breaking this up. If we were to break up 8/3 into sections of 1/3, how many sections would I have, or how many jumps would I have? Well, let's think about that. If we're trying to take jumps of 1/3, we're going to have to go 1, 2, 3, 4, 5, 6, 7, 8 jumps. So we could view this as, I'm going to do this in a different color, do it in this orange. So we took these 8 jumps right over here. So we could view 8/3 divided by 1/3 as being equal to 8. Now why does this actually make sense? Well, when you're dividing things into thirds, for every whole, you're now going to have 3 jumps. So whatever value you're trying to get to, you're going to have that number times 3 jumps. So another way of thinking about it is that 8/3 divided by 1/3 is the same thing as 8/3 times 3. And we could either write it like this, we could write times 3 like that, or if we want to write 3 as a fraction, we know that 3 is the same thing as 3 over 1. And when we already know how to multiply fractions, multiply the numerators, 8 times 3, so you have 8, that same color. You have 8 times 3 in the numerator now, 8 times 3, and then you have 3 times 1 in the denominator. 3 times 1 in the denominator, which would give you 24/3, which is the same thing as 24 divided by 3, which once again is equal to 8. Now let's see if this still makes sense. Instead of dividing by 1/3, if we were to divide by 2/3. So let's think about what 8/3 divided by 2/3 is. Divided by 2/3. Well, once
Times
again, this is
8.
like asking the question, if we wanted to break up this section from 0 to 8/3 into sections of 2/3 or jumps of 2/3, how many sections or how many jumps would I have to make? Well, let's think about it. 1 jump, just in a different color. We could make 1 jump, that's the same color as my 8/3. We could do 1 jump, my computer is doing something strange. We could do 1 jump, 2 jumps, 3 jumps, and 4 jumps. So we see 8/3 divided by 2/3 is equal to 4. Now, does this make sense in this world right over here? Well, if we take 8/3 and we do the same thing, saying, hey, look, dividing by a fraction is the same thing as multiplying by a reciprocal, well, let's multiply by 3/2. Let's multiply by the reciprocal of 2/3, so we swap the numerator and the denominator, so we multiply it times 3/2, and then what do we get? In the numerator, once again, we get 8 times 3, which is 24, and in the denominator, we get 3 times 2, which is 6. So now we get 24 divided by 6 is equal to 4. Now, does it make sense that we got half the answer? If you think about the difference between what we did here and what we did here, these are almost the same, except here we really just didn't divide, or you could say you divided by 1, while here you divided by 2. Well, does that make sense? Well, sure, because here you jumped twice as far. You jumped twice as far, so you had to take half the number of steps. And so in the first example, you saw why it makes sense to multiply by 3. When you divide by a fraction, for every whole, you're making 3 jumps. So that's why when you divide by this fraction, you multiply, or when you divide whatever's in the denominator, you multiply by it. And now when the numerator is greater than 1, every jump you're going twice as far as you did in this first one right over here. And so you would have to do half as many jumps. Hopefully that makes sense. It's easy to think about just mechanically how to divide fractions. Taking 8/3 divided by 1/3 is the same thing as 8/3 times 3 over 1. Or 8/3 divided by 2/3 is the same thing as 8/3 times 3 over 2. But hopefully this video gives you a little bit more of an intuition of why this is the case.
Thus.
So let's calculate what 2/5 divided by 7/3 is. And I encourage you to pause this video and try to calculate this on your own.
I'm going to do the
Well, we just have to remind ourselves that this is going to be the exact same thing as
2/5 times 3 is
over
7.
5, as 2 over 5 times the reciprocal of 7/3, which is
6/35.
3 over 7, which is 3 over 7. And then multiplying two fractions is pretty straightforward. This is just going to be equal to the product of the numerators. So 2 times 3, 2 times
Divided by the product
3
of denominators.
over the product of the denominators, over 5 times 7. 5 times 7, trying to keep the colors consistent. 5 times 7, which of course is going to be equal to 2 times 3 is equal to 6, and 5 times 7, I'll do this in a new color. Let's see, I haven't used the shade of blue yet. 5 times 7, of course, is equal to 35. So this is equal to 6/35.
Divide and write the answer as a mixed number. And we have 3/5 divided by 1/2. Now, whenever you're dividing any fractions, you just have to remember that dividing by a
6,
fraction
5,
is the
1,
same thing
and
as
1/5.
multiplying by its reciprocal. So this thing right here is the same thing as 3/5 times. So this is our 3/5 right here. And instead of a division sign, we want a multiplication sign. And instead of a 1/2, you want to take the reciprocal of 1/2, which would be 2 over 1. So times 2 over 1. So dividing by 1/2 is the exact same thing as multiplying by 2 over 1. And we just do this as a straightforward multiplication problem now. 3 times 2 is 6, so our new numerator is 6. 5 times 1 is 5. So 3/5 divided by 1/2 as an improper fraction is 6/5. Now, they want us to write it as a mixed number. So we divide the 5 into 6, figure out how many times it goes. That'll be the whole number part of the mixed number. And then whatever's left over will be the remaining numerator, the remaining numerator over 5. So what we'll do, we'll take 5 into 6. 5 goes into 6 one time. 1 times 5 is 5. Subtract, you have a remainder of 1. So 6 over 5 is equal to 1, whole, or 5/5, and 1 over 5. And 1 and 1/5. This one comes from whatever is left over. And now we're done. 3/5 divided by 1/2 is 1 and 1/5. Now, the one thing that's not obvious is why did this work? Why is dividing by 1/2 the same thing as multiplying essentially by 2? 2 over 1
Yo,
is
just
the same
explain
thing as
this
2.
in the previous
To do
video.
that, I'll do a little side, fairly simple example, but hopefully it gets the point across. If I were to take, let me take 4 objects. So I have 4 objects. 1, 2, 3, 4. So I have 4 objects. And if I were to divide it into groups of 2. So I want to divide it into groups of 2. So that is one group of 2. and then that is another group of 2. How many groups do I have? Well, 4
I
divided
have
by
two
2, I have
groups.
2 groups of 2. So that is equal to 2. Now, what if I took those same 4 objects? 1, 2, 3, 4. So I'm taking those same 4 objects. Instead of dividing them into groups of 2, I want to divide them.
By
I
one
want to
half.
divide them into groups of 1/2, which means each group will have half of an object in it. So let's say that would be one group right there. That is a second group. That is a third group. I think you see each group has half of a circle in it. That is the fourth. That's the fifth. That's the sixth. That's the seventh. And then that's the eighth. You have 8 groups of 1/2. So this is equal to 8. And notice, now each of the objects became 2 groups. So you could say, how many groups do you have? Well, you have 4 objects, and each of them became 2 groups. Each of them, I'm looking for a different color, each of them became 2 groups, and so you also have 8. So dividing by 1/2 is the same thing as multiplying by 2. And you can think about it with other numbers, but hopefully that gives you a little bit of an intuition.
Explain the last part, the
And
multiplication.
notice, now each of the objects became 2 groups. So you could say, how many groups do you have? Well, you have 4 objects, and each of them became 2 groups. Each of them, I'm looking for a different color, each of them became 2 groups, and so you also have 8. So dividing by 1/2 is the same thing as multiplying by 2. And you can think about it with other numbers, but hopefully that gives you a little bit of an intuition.
Same as multiplying by reciprocal, the inverse. Two thirds times 3/8. 9/16. To improper fractions and multiply by reciprocal. Oh, it's just gonna be in 9. No, and 7/5, right? 6 and 56. 2, 8, 11. 11. It's gonna be 4, 11 reciprocal. And then it's gonna be 4 times 8, 3, 3, 3, 3. Okay. Uh, 2, 14 over 5. We have 6 over. You have 8 over 49. You have 36 over 7. You have 81 over 4. And you have like 16 over 81. Divide mixed numbers. Okay, so we have 12, 14, 28 divided by 3. 8, 8, 11, 11 divided by 3. I believe this one's gonna be like 11, 12. 8, let's say 1. And then 9. For the bottom part, we have 8 times, and we have 40. And then for the bottom part, we have 5, 9. For the first part, we have 3. 3 times 7 plus 4, 11, 33. For the bottom part, we have 33 times 4. Holy shit, that's a lot. You know what? Let's convert this first. So we have 33 over 10 times like 7 over 7, 11, 33 times. Yo, this is insane. Then I mean, I could just do this, right? We have 1 and 3. We have 21 and 10. 21, 10, I'm pretty sure. Oh, we're almost done. Let's go. We can finish this.
A baby's t-shirt requires 4/5 yards of fabric, or 4/5 of a yard of fabric. How many t-shirts can be made from 48 yards? So what we want to do is we essentially want to say how many groups of 4/5 of a yard can we make with 48 yards. So you literally view this as we want to take 48 yards. So we want to take 48 yards and divide it into groups of 4/5 of a yard and say how many groups are there, because each of those groups can make one baby's t-shirt. If you give me 4/5 of a yard, one baby's t-shirt, so the number of groups of 4/5 is the number of baby's t-shirts. Now, when we divide by a fraction, we just have to remember that that is the same thing. That is completely equivalent to multiplying times the reciprocal of the fraction. So if we have 4/5 here, that'll be 5 over 4, the reciprocal. Now, this still might say, hey, I have a whole number here and a fraction. You just have to remember, any whole number can be written as a fraction. This is the same thing as 48 over 1 times 5 over 4. Now, we could just multiply it out at this point, figure out what 48 times 5 is, and that'll be over 4. But that'll get big numbers, and it'll be hard to kind of divide and all that. But we could divide at this stage right here. We could divide the numerator and the denominator by 4. Or we could say, look, this is going to be equal to 48 times 5, whatever that is, over 4. Now, let's divide the numerator by 4. Well, we could divide 48 by 4. And we will get 12. And we could, whatever we did to the numerator, we have to do the denominator. So if we divide 4 by 4, we get 1. So then we're left with 12 times 5, which is equal to 60. 12 times 5, which is equal to 60 over 1, which is the exact same thing as 60. So you can actually make 60 children's or babies' t-shirts from 48 yards if each of them use 4/5 of a yard.
A serving size of blueberries, 1/4 of a bowl. If there are 3 bowls, how many blueberries can? So it's gonna be 3 divided by 1/4. Which problem can we solve with 1/3 divided by 4? The local ice cream shop is opening for the summer. They have 4 liters from each liters. Erica's 1/3 bag of candy. For her birthday, she receives 4 more bags. I think this is the one. Oh shit. 4 friends are running in a relay race. The race is 1/3. How many? Wait, what is the same thing? How many kilometers will each friend run? 1/3 divided by 4. Oh shit, yeah, this makes more sense. Chamberlain wants to bottle 1/8 of her apple cider. Is this quiz? Okay, good problems. Wait, what? Where? Wants to bottle 1/8 of her bottle of her apple cider. She pours the apple cider evenly among 6 bottles. This is confusing. She wants to bottle 1/8 of her apple cider. She pours the apple cider evenly among 6 bottles. What the fuck? Then among 6 bottles. Okay, so I guess 6 times 1/8. Nice. Wait, what the fuck? Shit, I'm an idiot. Yo, this is hard. Could be this one, I think. It's gonna be like 1 over. Which problem can solve with 5 divided by 1/6? How much? Corners? No, but 5k. Corners 1/6 bago puti. He wants to share the chips evenly. Oh shit. Oh, it's 1/6 divided by 5. Let's see. Brennan's planting seeds. He has 1/5 of a pack of seeds and 5 flower pots. He wants to use the same amount of seeds in each pot. What fraction? So I think it's 1/5 divided by 5. Which problem can we solve with 1/2 divided by 7? Walt has 7 hamsters. Each hamster weighs... What? Kara ordered 7. No. Sonic trail mix. Nikita has 1/3 of a kilogram of trail mix. She wants to share it equally among herself. Nikita's 1/3 of a kilogram of trail mix. She wants to share it equally among herself and her 2 cousins. How much? So this 1/3 divided by 3. Excuse me, sorry. Diana is painting statues. She has 7/8 of a liter of paint remaining. Each statue requires 1/20 of a liter of paint. How many statues can she paint? She has 7/8 of liter paint remaining. Each statue requires 1/20 of a liter. So I guess if you have 7, 8, and then we're gonna multiply by 20. 1 and we have 8 over 7, 140. Oh shit, I can actually just 4, 10, 5, 2, we have 35 over 2, right? Marcus is picking songs to play during a slideshow. The songs are 3.5 minutes long. The slideshow is 31 and how many songs will play in the slideshow? Okay. It's gonna be like 31, 62, 63 over 2 times 1 over 6, 7. How many songs will play in this slideshow? 2 over 1, 63 times 1, 2, 42, 44, 441. Holy shit, it's a lot of song. It's like 200 songs. Yo, is this even correct? What if I try the other way around? Which makes more sense? Let's see. So you have 7, 2 over 2 over 63. Now this one doesn't make sense. Yo, 440 was pretty huge. It's not even. Second, 31 minutes. 31 and a half. (31, 62, 63 over 2 times 1). No, it's not 1. It's 2 at the top. Then we have 3, 6, 7. It's 9 songs. Nicole is playing a video game where each round lasts 7.5 hours. She's scheduled 3 3/4 hours to play the game. How many rounds can Nicole play? Okay, so we have total of 4 hours. It's gonna be 4, 12, 15 times 12, 7. It's gonna be 1, 3, 45 over 7. A piano teacher has 4.5 hours available to teach in each night. Each lesson will last 1.5 hours. Okay. So you have 8, 9, multiplied by 2, 3, 9/3, or just 3. Amira has 3/4 of a bag of cat food. Per cat eats 10 of bags per week. 3/4 times 10, 1 of 30 divided by 4. So 15 over. Yo, is this correct? Let's see. Let's try again. I don't want to mess up. Amira has 3/4 of a bag. Per cat it's per week. So divide by 10, but then we're gonna multiply in reciprocal. 30 and 4, 15 and 2. A relay race covers 1.5 kilometers, and each runner on the team will run 1/4 a kilometer. How many runners are needed for a team? Okay, so it's gonna be 2, 3, 2 times 4, 1, 2, 6 runners. Right, 6 runners, right? Erica can run 1/6 of a kilometer in a minute. Her school is 3/4 of a kilometer away from home. How? So 3/4 divided by 6. Divided by 2, with 2, with 3, 9 over 2. 4.5 minutes. Okay, great, awesome. I'm now in shit. Start quiz. 5 questions. Which problem can we solve with 2 divided by 1/8? Kim wants to run a total of 2 kilometers 1 week. He runs 1/8. How many times would Kim run? Divide. Write the quotient in lowest terms. 3/5 times 2, then 4, 5, 6, and 25. Yo, is this right? A pizza is cut into slices that are each 1/6 of a whole. John is going to eat 1/2 of the pizza. How many slices will John eat? 3 slices. Wait, what? A pizza is cut into slices that are each 1/6 of each. So, let's try this if this is gonna work. It's 1/3. If it's the other way around, it makes more sense. It's 3, not 1/3. Okay, so 1/2 of the pizza divided by 1/6. Bobby wants 7 kilogram of gold. He wants to share it equally between himself and one friend. So we have 1/7 divided by 2. How much gold will each person get? Divide, right? The Russian form. Okay. 9 over 16. 16, right? Yeah. Times 5 over 4. We have 1, 4, 20 over 9. Wow, okay, cool. Unit test, let's go. 5, 6 minus 1/4. Wow, holy shit, 27 items are filled. Holy fuck, okay. Need to have the same denominator, so it's gonna be 12 for both guys. So 12, then 5, 10 minus 12, 3 plus 7 over 12. Nine fourths or 6/8. It's gonna be 3, 12, 14 times 7, 14 over 21. Oh, it's gonna be 2/3. A 16.5 kilometer stretch of road needs repair. Workers can repair 2.5 kilometer of road per week. Oh, okay. So you have like 33. A kilometer workers can repair. How many weeks will take to repair this stretch of road? So we're gonna multiply. For the top, 4, 8, 9. 1, 2, 66 over 9. I think we can simplify this even further. I mean, this both are like 3. So we have 3, then we have 11. So we have 22 over 3. That makes sense. This 7, 8. This 8 over 8. Clearly, okay, I can select. 8 over 8 is greater than 7. Which expression represents the shaded length of number line below? So we have 1/2 and this is 1. Oh shit, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a half, right? Or 1/2 of 5, 6. 1, 2, 3, 4, 5. Just 5, 6, 1/2 of that. Choose the number line to represent the equation. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 4/5. This cake is cut into 6 pieces. Is each piece 1/6? Yes. Move the dot to 1/2 of the number. Okay. Order numbers from least to greatest. Well, this is greatest. 1, 6, 9, 10, and 7. Subtract. Okay. It's gonna be 1/6 minus 2/6. Then plus 6 is gonna be 8. 8 minus 5, and this is gonna be 1 plus 6 is 7. So we have 5/6. We have 8 minus 3. Oh wait a minute. 8 minus 5 is 3. 3 and 5 is 6. Let's do it again. We have 9 and 1, 6 minus 5 and 2, 6. I'm gonna grab 1 from this guy. So we're gonna have plus 6, 7. Now it's gonna be 7 minus 6 is 5/6. That's 8 minus 5 is 3 and 3 into 6. Yeah. Marcus played 3 different activities this week after school. The time spent playing is described below. Marcus swam more than he played soccer. Swam is 9/10. Soccer is 2/3. That is definitely correct. Okay. Marcus played soccer less time than he jogged. No, this is greater than half. Played soccer less than, this is half. This is greater than half. Marcus jogged for more than the time he swam. Oh no, it's A. Jeff has 7 blue balloons. He has 8 total balloons. What fraction of balloons are blue? 7, 8. Multiply. 4/5 times 3, 6, 8. 6, 8, 3. We'll have nothing. Okay. Choose the equation. Which equation shows the same relation? Oh shit. Okay. I might fuck this one up. No, this one's correct. This one's not right. 1/5 is the same as. Three divided by 6. Wait, what? Oh, I think it just simplified. It's 1/2. 4/8. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. William, his brother, and their 3 sisters won 1/2 of the sums. What fraction of the prize money will each sibling receive if the 5 and split? So 1/2 divided by 5. How can we calculate the shaded area? That's 2 times 1/3 and 1 plus 1/3. Which expressions match the following number line? Choose two answers. 3, 8 plus 3, 8. 3, 8 times 2. 2 times 3, 8. What is 4 times 1? Okay. 4, 1 times 8, 11. Yeah, 2, 1. 11. Choose two answers. 11, 2. And also we have like 5 and 1/2. Kate and Tyler are working at their lemonade stand. They have sold 2 and 1/2 pitchers of lemonade and now have 1/3 of. How many pitchers lemonade did they start with? Kate and Tyler are working at their lemonade stand. They have sold 2 and 1/2 pitchers of lemonade and now have 1/2 of pitchers left to sell. How many pitchers of lemonade did they start with? Holy shit, what? Whoa, this is insane. Wow, I might make a mistake in this question. Kate and Tyler are working at their lemonade stand. Okay? They have sold 2 and 1/2 pitchers. It's like 2, 4, 5, which is also equals to just 2. They have sold 2 and 1/2 pitchers of lemonade and now have 1/3 of a pitcher left to sell. Holy shit, okay. Let's see. If I multiply this by 1/3, it's not gonna make sense. Okay, 2 and 1/2 pitchers of lemonade and now 1/3 of pitchers left to sell. Okay, am I just supposed to add these? There's no multiplication here. This is just addition. It's 4. Oh, not 4. They have sold 2 and 1/2. 2 and 1/2 is equivalent to. Yeah, that one. 2 times 2, 4 plus 1 is 5 plus. And now have 1/3 of pitcher left. So 1/3. So make the 6. So we have times 3. We have 15 over 6 times 3, right? Times 3 plus 6 of 17 over 6. Okay. Let's try this again. 2 and 1/2, that's equivalent to 2 times 2, 4 plus 1 is 5. And then plus 1/3 plus 1/3. Then 6 times 3, 15 plus 6. Please be correct. Please be correct. Yeah. Okay. You compared 3/4 and 9/8 by comparing each fraction to 1. Step 1. 3/4 is less than 1. That's true. 9/8 is greater than 1. That's true. So 3/4 is less than 9. That's true. Nick did not make a mistake. Write in simplest form. Holy shit. This is divisible by 6. So if divided by we get 10. For this 48, am I supposed to make this mixed as well? I'm gonna make it mixed. 8. It's gonna be 5, 4, or oh my gosh, I'll make it 5, 4. I'm gonna make a mix. Move the dot to graph 9, 6 on the number line. Oh. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Move the dot to the graph fraction equivalent to 9, 6. D 1, 2, 3, 4, 3, 2, 9, 6, 3. Yeah, I mean, if I divide this by 3, you get 1, 3. I'm getting really paranoid about this, but I'm pretty sure it's correct. I'm just paranoid. If divided, like, if I simplify this, we divide by 3, and we have 3, then 2. Last question. What fraction is located at point A on the number line? It's 3/4. 1, 2, 3, 4. So 4 parts, 1 whole, 3/4, 3/4. This is the last question for this unit test fraction. Come on, let's go. Leveled up 51 skills. All attained mastery. Mastery 100%. So good. Yeah. Never give up, never surrender. 100% for fractions. 40 hours. But I would have liked it if my previous video is connected. I don't want this into 2 parts. Maybe I'm gonna edit this video to like combine them together. Okay. So arithmetic, how much percent do I have? 72%. That's so good. Okay, so okay, the decimal's the last one. Then after that we're gonna go to pre-algebra, which is really 26%. Holy shit, that's insane. Join a class. Oh, okay. Gonna leave it here. 15% on the world of math progress. So yeah, this ends my, I think this is my 7th session, and my 6th, I don't know. Holy crap, I don't. So yeah, That's for the fraction part, and then tomorrow I'm gonna do the decimals. Gonna start with decimals. Okay, bye.